Well, good morning and welcome and thank you for joining us for the British Amateur Television Club CAT22 convention. I'm David G7URP and together with my ex-whale, Tammy M0TC, just sitting to my left, as Vision Mixer, we're very pleased to help the BATC stream this live event today. Martin G4FKK has been active on amateur television since the 1970s and was elected as the BATC chairman at the general meeting in August this year. So I'm pleased to introduce Martin, who will now give you a brief update on the British Amateur Television Club.
Yeah, thank you, David, and just turn the audio down here. And welcome to everybody to CAT22 Online Part 2, as it were. And as David said, I was elected to the committee back in the CAT22 Part 1, and slightly surprised to find myself chairman at the end of that. So to all of you who've not seen me before, this is who I am. Fairly active on the satellite when I can be. Unfortunately, I'm back at work at the moment. I thought I'd retired, so I have slightly less time at the moment, but we'll be getting back to business in the next few weeks, hopefully. Anyway, we got a packed program today. Just give you a quick update of where we are on the BATC. We've got a very healthy membership, 1420 at the last count. We're financially stable, which is unusual these days. The committee of 10 are pretty active. I'm going to be more active, say, once I've retired again. But we do rely on volunteers. So anyone who's got anything interesting to add to the club or wants to help out in any way, you're very, very welcome indeed. This year we had the CAT22 meeting at Coventry at the Aircraft Museum. We're doing the online one now. We've got the weekly nets on Thursday nights. Anyone's welcome. In fact, everyone's welcome from anywhere in the world. And you don't have to be a BATC member, although obviously that is appreciated. We're active on contests, activity weekends, rallies. Dave and Noel and several of the members have been very active in the various rallies that have been around this year. And we're going to have a packed programme for next year. You'll see there's question marks at the moment because dates haven't been finalised, but we'll be keeping you all entertained throughout the coming year. Lots of projects going on. I won't drone on about those too much because you're going to be seeing some of those throughout today. The various services we offer. Obviously, CQ-TV is extremely well produced magazine, and thank you to the team that does that. There's the shop, bargain prices there, the website. And I would recommend people check out the website and the forum in particular. If you've got any queries, there's an answer there somewhere. Sometimes it can be hard to find, but you'll find everyone very helpful. Just ask. You can contact me directly at chair@batc.tv. Nearly gave my BBC email there. And please feel free. Please contribute to the forum. If you see something needs updating on the wiki, you can do that. Volunteers always welcome. Always welcome. Put your name down to join the committee. Look what happens. And we will be looking for a new membership secretary in the coming year, so the next few months. So anyone would like to volunteer for that, please let one of us on the committee know. So today it's a packed programme, as David said. We got Tom up next. I'm using some of his software as we speak to watch the things going on Oscar 100. For that, many thanks, Mike G0MJW. If you're listening, Mike, you might have to pump up the volume a bit. You're not quite D0 here yet. Got an interactive Q&A session coming up, so it'll be interesting to see how that goes. And we've got EMF for microwave. No, we haven't. Sorry, I'm going back in time there. But there is an important bit at 1:15 to watch about the future of 23 SEMS, not just here, but all over the place. Few rules here. Feel free to ask questions in the chat on Zoom or the BATC stream. Try not to put too much trivia in. I know it's funny sometimes to do that, but it can get a bit difficult for the people running things to itemize questions and things. You will be muted until the lunchtime session, where we will have a good chat about what's going on and what we're up to. And you can find us on Zoom, BATC stream, and on Oscar 100. So there's no escape, basically. So enjoy the meeting. I shall hand back to David. Thank you, David and Tammy, for running this, and have a good CAT22 online. Back to you, David.
Thank you very much, Martin. Well, now I'm pleased to introduce our first presenter today, Tom ZR6TG, who comes to us live from his workshop in South Africa. During the past year, Tom has published a number of innovative DATV software tools, and he'll describe them in his talk. And I'm pleased to tell you that you can ask questions or make comments using either Zoom or the BATC streamer during his talk, and I'll read as many as I can to him after the presentation. But now, over to Tom. Welcome to CAT22, Tom. You're muted, I think, sorry. That's all right. I think it's on the Zoom, Tom, that you're muted, so.
There we go.
Got you there.
Excellent. Sorry about that. Good morning, everybody. My name is Tom, Zulu Romeo 6 Tango Golf, and I'm talking to you from sunny South Africa. My QTH is in Van der Bijlpark, which is it's a small town about 100 kilometers away from Johannesburg. And by day, I'm a research and development engineer, and after hours, a general geek. My interest in amateur radio started a couple of years ago when I was playing with high altitude balloons, and it blossomed into a fun new hobby with a special interest in both satellite, or especially satellites, both LEO and geosynchronous. Unfortunately, well, first I wanted to show a bit of my setup here at my QTH. As you can see, it's mostly satellite related stuff, although I do have the odd 2 meter and HF antenna there as well. Unfortunately, ATV and DATV experimentation in South Africa are basically non-existent. And my journey in DATV started specifically because of the QO100 satellite. More specifically, the wideband transponder on the QO100. There's more and more ZS stations from South Africa joining the fun every week. So I'm hoping this will start a bit more of a DATV experimentation revolution locally for us here in South Africa. So obviously, I'm fully aware that most of you guys are aware of the QO100, but if you're not, and if not, why not? The wideband QO100 transponder basically has a bandwidth of 8 megahertz and is designed mostly for doing DATV experiments, although there's room for testing with other experimental wideband digital modes. I'm not going to go into too much detail on how to use the QO100 wideband transponder, as the BATC wiki has lots of great information on getting started and going on that. I'm also still very much new to ATV and DATV. Only been playing with it since end of last year. So the following information that I'm going to share to you today in this presentation is mostly based on my own experiences. But as with most things in our hobby, there's many ways to skin a cat, which is why it's always important to share what we learn and also to have fun together. So today I wanted to share some of the developments around DATV software in the hope of starting more discussions about the software we use, how we can improve it, and to inspire more programmers to jump in and play along. The rest of this presentation consists of various projects I've worked on in the past year. Most of these are developed out of specific needs that I had, or just random experiments as I explore the various software that's already available. Keep in mind, this is just an overview. So if you see any of these projects that you want more details on and more documentation on, feel free to go check out my website, which is www.zr6tangogolf.co.za. So getting back to the QO100 wideband transponder, there's a lot of cool content on there, regular nets and regular transmissions on the satellite. But I always felt restricted to that I had to be in my shack to be able to view these transmissions. In a world today where services like Netflix are very common, why do I need to be restricted to my shack just to be able to for DATV reception? So the idea kickstarted a bit my first development, where I started to do some research about being able to view these transmissions while I was maybe lying in bed during the winter's night or busy elsewhere in and around the house. Essentially, I wanted to put the content on my home network. So after some research, I found the Longman software packages. This is essentially open source Linux DATV receiver that was developed by Heather Lamont back in 2019. And it's a command line application which does similar functionality than what the Minituner software does, except that there's no graphical interface to it. It does the same control and configurations. And the specific Longman project has been adopted by various other projects by the BATC. You'll find it in the RIDE receiver, in Portsdown, etc. Essentially, the video stream that is received by Longman is made available on UDP ports, and you can then use VLC to connect to it and view these streams. Further in my research, I actually found a version of Longman that was forked from the original one, and by Phil Crump. He was doing some experiments on adding a web interface to Longman. It seemed like it was still very much a work in progress, but one of the important bits that he added was a WebSocket interface. And over this WebSocket interface, you could basically get the status of the tuner, get all the information, and also send commands back. And that was essentially the last piece that was missing for my network idea to put something together. So the basic idea of the network DATV receiver is to pair the Minituner hardware with a Raspberry Pi with the custom Longman software. Controlling Longman with the required parameters such as the frequency to listen on and which symbol rates to use, amongst others, is then all done via the WebSocket. The video feed as received by the tuner is made available by Longman on a UDP port. We can use a Raspberry Pi for this network DATV receiver, specifically because there's not a lot of processing required. Longman doesn't actually decode the video and audio feed, but rather just pass the data along on a UDP port. So now that we've got a receiver, we essentially needed a client to be able to view these transmissions and control Longman. So this was the basic client that I started to develop to receive data from Phil's custom Longman. I aptly named it the Longman client. It receives status messages continuously over the WebSocket, and it also connects to the UDP port of Longman to get the video and audio. The client needed to be able to decode this video and audio, so it makes heavily use of the VLC development libraries for the decoding. The client can also send commands to the tuner via the WebSocket to change the frequency and other settings. I shared this test version with a few of my DATV friends, and lots of suggestions came in to improve it. One of the most requested suggestions was to add something similar to the QuickTune application that was developed by Rob Swinbank. Now, the QuickTune application essentially connects to the online wideband spectrum monitor. It retrieves the data that it needs, and it shows it on a simple interface. But it also has some smarts into it where it allows you to tune or select specific signals. So it can detect the signals, show some basic information about it, and you can, by clicking on it, tune your RIDE or your Minituner to the specific to the signals. Luckily, all of the source code from Rob's QuickTune was available, so it was very simple to see how it worked and to implement that in my Longman client as well. I also managed to do a few changes to his code and push it back to the repository, which is essentially the beauty of open source. So speaking of the wideband monitor, it works great in principle. But if you're in a country like mine where power and internet is not always guaranteed, what do you do when the internet is down? We don't want to start transmitting if we can't monitor the spectrum, since you could potentially interfere with someone else's signal. This also applies to having a mobile DATV setup or station, something which I'm looking into very much. And you don't know, depending on where you are, you won't necessarily have cell phone service. So I started digging into how the BATC actually put together their online spectrum monitor. And in short, it can be broken down into the following pieces. There is a FFT server that was also developed by Phil, and it's pretty smartly done. The FFT server uses an SDR and receives the spectrum of the complete wideband transponder directly from the satellite. It does some fancy math stuff that I'm still figuring out, but essentially it outputs a clean average FFT that shows the complete spectrum. It outputs all of this data basically on a WebSocket. From there, it's just about any application can connect to that WebSocket and retrieve the data. In the case of the online BATC server, the website that we all casually visit connects to the FFT server and gets the data and displays it in a way that makes sense to the user. This is the same data that QuickTune and ultimately Longman client uses to create Smart QuickTune. So I was thinking to see if there's a way that we can essentially replicate this in an offline way for if there's no internet. Since the code of the FFT server is available on the BATC repo, I grabbed a copy from there and I went about getting it to run on a Raspberry Pi. It's not very processor intensive code, so Raspberry Pi 2, Raspberry Pi 3 is more than adequate to run it. It turned out to be quite simple to get the original code going. The more tricky part is now that we've got the data coming in, we needed an interface. So because we're already running a Raspberry Pi with the FFT server on there, it was just a simple way of loading a web server on there. And what I did was I created almost a clone version of the online website into a more simplified one. Something that doesn't include the chat and some other stuff, but it does include the spectrum. And all of that then works in an offline manner. So you can still monitor signals regardless of whether you've got internet or not. The online version, however, still has real-time chat on the page, which is something that we're missing on our side. It's still a work in progress, but I've got a few ideas around that, which basically involves transmitting the chat data on the satellite as well. Maybe we can use something like the AMSAT DL high-speed modem, which is already running the multimedia beacon on a narrowband transponder. Keep in mind that if you want to try your own little offline server like what I did, is that you would need to use the AirSpy SDR as it was designed initially for that. And the main reason it used that specific SDR is that it needed to have the bandwidth to pull the complete spectrum in one go. One of the ideas that we're experimenting with is to change it to use an RTL dongle, one of the cheaper SDR dongles, which you can essentially get the same effect by scanning the spectrum in bits and pieces and then putting together a bigger picture. So that's still something that's a work in progress. So other advantages of running an FFT server like this on a Raspberry Pi in our shack is that we can actually connect our QuickTune application to it as well as Longman directly to it. So when the internet goes down in those cases, you can still use those tools. What I like about the Raspberry Pi is that I could easily throw a LCD on the Pi and create myself a little gadget for the shack. Something that can show the time and even a simple spectrum of the wideband transponder. This works great for quickly monitoring the activity on the QA100 DATV without having to open up any programs or sitting behind a computer. This was a fairly quick hack put together using Python and a graphics library called Pygame. We already have all the data supplied on the FFT server, and since it can take multiple connections, why not make use of it in a few more places? By the way, there's also the same shack gadget also works with the online version of the BATC spectrum monitor. So you don't have to do the offline version if you want to build a gadget like this. Now, if you go back to the modified Longman from Phil, you will remember that it basically allows us to get information on currently tuned signal, basically the status of the receiver. As I said, we get all of this information by our WebSocket, and because it allows multiple connections on the same port, we could retrieve this information in multiple applications. Another one of the issues that I had was to be able to easily fine-tune my dish to the QA100 beacon. One of the features that I added into Longmint was basically a little dish calibration helper. It was actually suggested by one of the guys using it as well. And it basically shows you the signal strength in a nice big view. And you can also enable some sound where the frequency of the sound will change depending on your signal strength. This works great if you can see your laptop, and since we're a network, you can essentially take the laptop on top of the roof as well and fine tune it there. The problem with that is I almost had a few near misses where my laptop almost fell off the roof. So I figured I needed to implement something a bit more safer. Now, one of the ideas that I had was to maybe, why can't I use my cell phone for this? We're all carrying around our cell phones. It's a lot more smaller and easier to use. So since all that information was already available from Longmint, it was pretty easy to develop an application that receives the information in real time and shows it on a screen. So what you see there is essentially the Windows version of the little app that I developed. The framework that I used for it was Flutter. Flutter is a mobile application framework that allows you to develop something that is cross-platform. So, excuse me. So the same application will work on an Android, iOS, even Windows or Linux machine. So it's a fairly simple application, but it works wonders when adjusting the dish. To use it, simply tune to the QA100 beacon. It will show the currently received signal as a real-time value and an average value over the last few seconds, and it will also graph it out for you. So you get a real-time feedback as you're adjusting your dish. The source code for this is all completely available, so you can go and further develop it even more depending on the needs that you have there. It was around this time in all my experimentation that I decided to build a winter hill system using the advanced receiver design from the BATC wiki. As you know, most of you know, this is a great receiver that allows us to receive 4 DATV transmissions at the same time. And it's a completely self-contained unit with the Raspberry Pi just plugging into it. This appealed to me because if we apply the same concept of the Longmint client onto it, then we can receive different channels on different devices because we've got 4 channels that we can share. It's essentially the perfect network DATV receiver. The Winter Hill software was originally designed and developed by Brian, G4EWJ, and I reached out to Brian with some questions and quickly realized that the core of it was also using a modified Longmint instance. At this point, I forked the Winter Hill code to a separate repo and modified it with the same WebSocket code that was in Phil's version of the Longmint code. So a couple of changes to our Longmint client, and we now had a Winter Hill client. Completely the exact same concept with the same functionality, but with the ability to tune to 4 different channels. And it also allows us to have one client running on one PC, another client running on another PC, and both of them being able to watch different channels since we have 4 channels available. We now have the same type of control of the tuner that we had in Longmint. But like I said, with 4 UDP ports for receiving video and audio. I believe there's a lot more that we can do with the advanced receiver in Winter Hill, and I still have lots of different ideas I want to try. So the projects I've shown you up to now has mostly been more of the bigger, more polished projects. But in between, I've been playing with some various experiments and proof of concepts. And essentially, the first proof of concept is very similar to the Longmint client. I just asked myself, why do we need to restrict ourselves to a computer when we all carry around cell phones, same as the calibration aspect? And so I developed another little app in Flutter, which is the exact same concept as the Longmint client in that it connects to the Longmint server and receives the status of all the signals that are there, and also live video and audio from there. Android's got some very nice VLC development libraries that allowed me to be able to decode the video and display it as well. This one was a bit more of a challenge as your screen estate is a lot smaller than from a PC or a laptop aspect. So especially one part I had a problem was the spectrum monitor or the quick tune from Rob. And I ended up, you'll see in the bottom left corner there's these blue buttons. And what I ended up making is creating dynamic buttons that will appear for each signal detected on the spectrum. So then you can just select the signal by clicking on a button and it will tune Longman to that signal. There's still a few issues around the software, but the general concept works quite well. And I can now use my tablet or cell phone and anywhere on my network be able to view all the transmissions on the QA100 satellite. Another interesting part of this would be to combine it obviously with the winter heel as well. Some of my friends that's been playing with the beta test versions of the Android client has also managed to load it on an Android TV. So maybe there's some room where this can be expanded to these Android set-top boxes. Maybe that could be a different type of light receiver. Again, all just ideas that I'm throwing out there to get more people interested in playing and coding with it. So the Android client was interesting and it works, but if we're going this way, then why even limit ourselves to specific phones? How about we just make it accessible via our website? Now, this was a fun experiment because there are so many ways to do this. The initial attempt of this consists of a Linux machine. Unfortunately, the Raspberry Pi just doesn't have enough juice for the encoding and decoding that I needed to do. It was all still very inefficient, so I'm sure there's ways that can be improved to, at the end of the day, end up going onto a Raspberry Pi or a Jetson Nano. The core concept is a web server with RTMP extensions. We use FFmpeg to take the video audio from the Longman UDP port, and then we encode it with the right codecs to stream it as an RTMP stream on our network or out on the internet. So we can essentially open a browser on any device and view the stream. So we are a lot less limited to the specific devices. The next step would obviously be to add some navigation and tuner buttons. Well, I mean, that's a simplified website thing. And it's very easy to do with Phil's WebSocket code on Longman. And then we can essentially end up with a web Longman client. Which I'm pretty sure is we just went back into a circle back to the original reason why Phil started modifying the Longman to include a web interface. But it just goes to show that with the power of the Longman, because it's so simplified and generic, we can easily get the data and get the video and audio and use it pretty much anywhere. And then another quickie project that I was doing in between was when I started having a look at the light receiver. Again, based on all the instructions that I got from the BATC wiki. But I realized that I didn't have a decent remote control to control the receiver. So as part of playing with the mobile applications, I built a little Android remote control app that connects to your Wi-Fi network and via that connects to the light. And that can be used as a normal remote for controlling a light. What's nice about this, usually if you grab a random remote and hack it to make it to work with a light, you end up with all kinds of buttons you don't need. With this, we've got we can custom design the remote to make it look and work the way we exactly want it to. And then even possibly add the wideband spectrum monitor into the remote as well. It's nothing that big special, but I figured let me share that because it might be interesting and helpful to anybody who wants to build a light receiver who doesn't have a remote control. And then lastly, the last experiment that I did that I wanted to share, which is not necessarily DATV related, but it does integrate well into a DATV setup. As most playing on the QA100, I use a Pluto SDR, and to prevent losses on my signal, I have the Pluto SDR and amplifier in a box on the roof next to the dish. Now, typically one would use one of those USB to network adapters to put it on the network, but I experienced some issues with the USB adapters, especially the ones that I could find locally in South Africa. They work fine for most, your usual SDR console, narrowband aspect, and even some DATV. But especially if you start doing some digital modes or playing with a high-speed modem, for example, it started giving me some issues on the throughput. And I found a note on the AMSAT-DL wiki regarding USB adapters that when using the high-speed modem specifically, they recommend a specific adapter. Since I couldn't find the recommended adapter locally, I decided to try something else. Instead of using the adapter, I plugged the Pluto SDR directly into the network port on a Raspberry Pi. Since the Pluto SDR, once plugged in on USB, already enumerates as a Ethernet device, all we really need to do to make this to work is to set up firewall rules to port forward the incoming data on the Raspberry Pi to the Pluto SDR and vice versa. In my case, I used IP tables, but there's lots of different firewall packages. So it all depends a lot on the distribution you're running on your Raspberry Pi. And again, it hardly uses any processing. So even as simple as a Raspberry Pi Zero with a additional head that gives a network port. As I was saying, it could be as simple as using a Raspberry Pi Zero with a Ethernet head on it. And like I said, all you need to do is just forward the ports. Now, there's a couple of ports that you need to keep in mind if you want to pull this off. First, you need port 22 to be port forwarded, as that's your SSH access. Keeping in mind that you don't want to port forward port 22 from the Raspberry Pi to port 22 on the Pluto SDR, because you still want to be able to SSH directly into the Raspberry Pi. So what I did on mine was my incoming information or data connections on port 23 was then forwarded to port 22. Other ports you will need is port 80 for the website access on the Pluto, port 30431 for SDR software, like SDR console and such. And if you're running one of the custom DATV firmwares, you also need to forward the UDP ports or the RTP ports that you're using to stream in the video, which on mine is typically 8282. Now, before you tell me that it's a waste to use a Raspberry Pi just for putting a Pluto on the SDR, remember you can do so much more than that Raspberry Pi. For example, in my station, I added a little I/O board where I can connect. I've got relays on there and I've got analog inputs in there, so I can add in various temperature sensors and current sensors. So the box on top of my roof next to the dish can now be monitored using the same Raspberry Pi that I'm using to forward the information to the Pluto SDR. So I installed something as simple as Node-RED and interface that to the various sources. So now I've got a little dashboard that I can use to toggle the PTT, view the various sensors, and even add outside information like the weather or the QA100 spectrum monitor. So there's a lot of things that you can do with it. So I don't see it as a waste of using specifically a Raspberry Pi on it. And that basically concludes the overview of some of the projects and experiments I've been playing with. None of these projects would have been possible without the support and help from the BATC and various BATC members. And also a very big thank you to the guys from AMSAT-DL who made it possible for us to play with a satellite like this. There's so much things we can do with it, so much room for experimentation. We just need to jump on it and try it out. I would also like to thank all the various testers that were willing to put their hardware at risk with all my crazy software ideas, and then all the guys that also bought me a beer or two in between. If you wanted to get more information on most of the stuff that I showed to you now, you can just go to my website there, www.zr6tg.co.za. It's got much more documented stuff on there than what I showed now. You can always, if you have questions, hit me up on Twitter. That's probably the easiest way. And then obviously, have a look at the BATC website. There's tons of information on there. It's a good place to get started, as well as the AMSAT-DL website. Okay, I'd like to thank everybody for your time, and I hope it was an informative presentation.
Thank you. Thank you, Tom. No, it's not goodbye, as you know, because you've kindly offered to stay and answer questions, and we've got quite a while actually. We've got 20 minutes or so. So if you've been watching this at home as I have and finding it incredible, all of the different projects and ideas that Tom has been involved with, then please ask those questions and make those comments now, either on BATC messaging or on Zoom chat as well, and we'll read as many as we can to Tom. I love that remote control app as well, Tom. I'd missed that one. It looks really cool, actually. That's just any Android phone or tablet, is it? You're muted again, I think, Tom. Sorry. That's all right. That's okay. I can't do it. I can't unmute you, unfortunately. There we go. So that was for just almost any Android sort of phone or tablet?
Uh, Essentially, yeah. I use the same Flutter framework for it as well. So in theory, it can be compiled actually for iOS as well. It can even run on a Windows or Linux PC. The only reason why I didn't release a iOS version is you've got to jump through a few more hoops to get that compiled for iPhone. It's something I'm looking into. But essentially, it can be compiled and working on any iOS device. It's fairly dynamic and flexible, and all it does is connects over the network to the light interface. So it was a quick little project, and but it works quite well. So I'm very happy with it.
It's lovely. Yes. Okay. Well, we've got a few questions already coming in. Can I just ask you, if you do sign into Zoom, maybe you're not don't use it that much often, if you can sign in with your name and your call sign, if you have one, that would be really helpful, because otherwise I think it defaults sometimes to a number and things, and that makes it very difficult for me to just read out your name if all I've got is a number in front of me. So that would be really good. We have got some questions though. As I said, I'm not sure quite what this pertained to. It was around about 10 minutes ago. Justin Cockett said, this would be cool, Tom, Apple TV 2 ? So I'm not quite sure what you were talking about 10 minutes ago. Does that make sense?
Yeah, I think Justin's referring to the Android version of the Longman client that we're using on an Android TV device that we experimented with. The Apple TV, it's quite an interesting idea. I'm fairly certain it would work. Again, it's also designed on the Flutter platform. So I would need to do some research to see if it actually supports the Apple TV side of things. But in theory, there's no reason why it shouldn't work that way. The only problem with Apple hardware, and which I'm not a fan of it, is on the Android side, if you develop something, it's fairly simple just to distribute the APK and the guys can install it and such. On Apple, it's a lot more involved, as they can't just go and install any random software on the Apple devices. So you need to have a developer license and some Apple hardware to test on it. Those things are all, it costs a bit of money in that. But in theory, like I said, the Flutter framework allows compiling for Apple and such hardware. So it should all definitely be possible. I guess it all depends on, how many people are interested in it, and then we can try it out.
Yeah, and I guess if anybody out there is already working with the iOS and the various Apple operating systems as well, could give you a hand, that would be good, and maybe fast track you to help you with some of those things. Justin Justin came back actually and just said, just fantastic, love using the Pi for the Node Red station monitor. So thanks for that, okay. Justin.
Thanks, Justin.
Dave G8GKQ says, what software languages does Tom specialise in, formal training or self-trained?
I don't know if you can call it formal trained. It's more self-trained. I did computer science degree, which we didn't focus on very much on the languages. So a lot of it is self-trained in my career over the years. C, C#, Python, Rust, those are the type of languages I play mostly with. Yeah, I hope that answers it.
Yeah, sure. I'm just busy reading some of the questions and comments coming in. Rob VK3EHT in Australia says, great work, Tom. Wish Australia, though, had access to Oscar 100. I bet there's a fair few Aussies saying that as well.
For sure, yeah.
Gareth Evans says, how's the RPI satellite tracking project coming on? Might the software end up on auto tracking, e.g. satellites or moon?
Yeah, he's referring to one of the projects I didn't show today. I've been working on a Raspberry Pi satellite tracking software package as well. Yes, it can definitely do auto tracking of those of the moon and such like that as well. Anything that you can get a TLE file for can be pulled in and be used. I haven't tried the moon specifically yet, but it's coming along. As you can see, I got distracted a bit with the DATV project, but I'm still very much into developing the RPI tracker even further. In fact, I've got a portable little smaller dish setup going now as well, which I want to turn into a mobile Oscar 100 station as well as LEO satellite station. But that project is still very much a work in progress, so I'll share that at a later date.
All right, good. Well, thank you for all you're doing for this, and everybody else as well who's been involved with these projects. As I said, if you want to ask questions of Tom or make any comments or anything, now's the time to do it. Dave M5TXJ says he can't see the remote software on the website. I'm not sure which website, but maybe you can just clarify which website it's available on, Tom, please.
It's on my website. Let me just quickly open up a browser here, and
I
I
think
can
we
tell you
might.
exactly.
I think we can actually bring up your website here in the caption, which might help everybody at home. Here we go.
Let me just double check first that it's actually
Okay.
there.
Well, anyway, for anybody who wants to make a note of that, that's Tom's own website there, www.zr6tg.co.za.
See, I post, so the website I keep for the more formal stuff, and I've got another site which I use for the more blogging site. But it feels like a bit of advertising sharing that. You can also look on the BATC forum. I added in a post there with all the information that of the remote control, and also a link directly to the software. I'm fairly certain I posted it on the website as well, but I did post on another website. David, if I can share screen again.
Yeah, we can do that.
Just so I've got another little site that I'm just using but basically it's a few of the guys have wanted to buy me a beer, so I basically signed that up to this site called Buy Me a Coffee. It's buymeacoffee.com/ZR6TG. And so I put a lot of posts on there that is more of these smaller work in progress projects, just to keep people in the loop, and also to say thank you for them, adding a few bucks for a beer or two. So I've actually got it all on there. You can go view it there. I'll create another post on the website as well for it.
Can you just remind us again, Tom, of that website that you're looking at there? This was Buy a Coffee, was it? Can you do that again?
It's buymeacoffee.com/ZR6TG.
So your call sign at the end, okay.
That's right, yeah. Sorry, I thought I had it on the other website as well, but it might have gotten lost among the posts. But yeah, the easiest is if you have a look on the BATC forum as well. I've got it up there with screenshots and the APK, and the code is also on the GitHub for you to go check it out and edit from there.
Okay. A few other comments for you. Nigel2E0EHH says, thank you for all your help to be DATV. Well done. Lots of other people as well. Gareth Ovens saying wonderful stuff. And Paul G6MNJ, excellent projects. I fancy building some of these. Thank you. And Noel, I'm not sure if this is meant for me or us here, but anyway, I'll read it. Would it help if the chat was available as a low data rate stream rather than the embedded in a page? Maybe BATC should buy the Apple app license.
I think he's talking about the offline Spectrum monitor, to be able to, well, not just that, also the Longman, to be able to pull in the chat into that software. I think that's what you're talking about, no? Something like that would be great. We actually need to talk and see what we can do to get that information, because for a fully offline station, the missing link is the chat at the moment. And if we can, transmit it somehow via the satellite, we can pull it easily into that. And also, I'm not quite sure if it's actually available on the website itself to be pulled via our WebSocket, because then we can also integrate it into something like the Longman client or the QuickTune. Because my concern about the Longman client is that I'm worried, since it shows the spectrum, that a lot of people might not be going back to the website to be involved in the chat as well. And it's fairly important to stay on, or to be able to view their chat, just to see if somebody's doing maintenance or if you're interfering with anybody. So something like that would definitely be great. Then we can integrate it in all the other apps as well. And then it provides a fully offline version of, even if you can't send data back to the chat, even if you can just at least be able to view the chat and make sure you're not causing any issues on the transponder.
Yeah, it's great. Well, Noel has come back and confirmed that that's what he meant. A couple of other suggestions associated with that. Mike Willis has said we could put it in the metadata. Justin G8YTZ says, Noel, perhaps a WBHS modem. this is, I guess, something to discussion. And just to let you know,
That-
everybody, actually, that there will be an open discussion on Zoom at lunchtime, over our lunchtime today, an informal sort of session. So if you're on Zoom and you'd like to chat about any of this sort of thing, that's exactly what the lunch break will be for. And Mike Willis says perhaps it could be included in the beacon. And Noel's come back and said, we'll take a look at it. So there we are. Hopefully some others will help with that. Just going on to BATC, some of the messages there now. Dave has says, I have no call sign for Dave, and there's several Daves there, but I guess you know who you are. Have you been able to record the incoming stream, e.g. to record the various nets if you're not at home?
I'm glad you mentioned that. So I've actually got a Longmint version 2 in the works, where the original Longmint uses the VLC libraries, but there's a bit of an issue with the libraries, especially when it comes to the volume settings, and I've been fighting with that for a bit. So I started looking at alternatives, and one of the alternatives that I found is that you can actually use FFmpeg embedded in the C# application as well. And the beauty of the FFmpeg library is that you can easily record video as well. It seems to be working quite well. Depending on the codec of the stream, there's 1 or 2 streams that I can't seem to record very well, but for the majority it records great. And I've actually been doing recordings. I've got a couple of the previous conferences that I've recorded via that as a test. The app needs a bit of work because there's a few things that are hard-coded for my setup that needs to be changed in configurations and setting screens and stuff like that. But with that, you should be able to record video quite easily. Even add a timer to it so that you can say stop recording after a bit, or start recording at a certain time. And then I also added in an auto record similar to the auto snapshot on the original Longmint client, where if that's selected, any new signal that comes up while it's quick tuning, it starts recording that as well. So that's quite fun, especially if you know there's a net and you can get all these different video files in that. So yeah, give me a couple of days and then I'll have some more information on the website.
You've set yourself a target there, saying a couple of days.
Well, it's like I say, it's already working. It just needs a bit of cleanup to make it a bit more user friendly so that it's usable.
Lovely, you're really dedicated to this. It's wonderful. Mike G0MJW in kind of reply to Dave, but this might be helpful as well. He says you could do that with VLC record and or FFmpeg. Is what he's suggested, is another way around that.
Yeah, you can definitely do that.
And several other thank yous and congratulations and everything from people, including Chris ON1RC says, Tom, thanks for all these great developments. Echoed by lots of people, I'm sure. And Noel is...
Well, thanks, Chris. Chris was one of the guys that actually reached out to me about the dish calibration. And that evolved into a lot of ideas around that. So very thankful for it. Helps getting suggestions and ideas of what the guys want to do, because most of the software is developed to my needs, but everybody's got other needs. And some of the developments, if it's fairly simple, I've got no issue to quickly put it in there. So keep them coming. And then also I'm also cleaning it up, but the Longmint client and the Winterhill client software, all of that's going, all the code of that's going onto my GitHub in the next couple of days as well. So anybody can then jump on there and play along and develop along. I think that's the beauty of all of this, is just to be able that everybody can play along and contribute.
Yeah, I mean, I was going to ask you almost as a final question, really, from me, on behalf of probably everybody, is what are you working on next? You said you're working on a version 2 of that software, but other projects, have you got any in mind that you don't mind talking about? Bearing in mind that anything you say now you might get people asking you when, but... No,
that's fine. No, actually, I've been quite jealous of you guys in the UK of being able to do mobile DATV stations. I was inspired by Rob Swinbank's his van setup that he's got going. So my current next project is actually be able to do something similar to that, but more of a South African ruggedized version. So I recently got a small little 4x4 Jimny, which should be able to go anywhere in South Africa, and I'm busy putting together a system that will allow me to have a mobile DATV as well. Not so much a software project for everybody else to use, but more of a personal project. but that's the next big thing. I'll have video and pictures soon of a small little 4x4 with a dish on top somewhere, hopefully into a couple of beautiful parks in South Africa, doing the Sunday net from there. So that's the plan, that's the current project. So and then obviously the Longman version 2 and all the code going out as well. I know a lot of the guys are anxious to add more features, and it's not practical for me to always add it in, but by releasing all the code, it at least gives other people opportunity as well to work on it and modify it.
Oh, well, thanks, Tom. You said you were jealous of us in England being able to do mobile activity, but as Justin's actually said, and I was thinking the same thing, that we're often jealous, I think, of the weather you get there. So, yeah, maybe we can meet in the middle somewhere. This is almost it now. Yeah, we've got, Justin says, I was thinking how the quick tune extension could be used to have multiple repeater inputs, not requiring dedicated RIDE receivers for each band. And Noel has come back and said a stream not off air recorder app would be useful, as well as several others saying that. Dave M5TXJ said a beer is on the way, Tom, or a coffee, I guess, whatever you like. And
thank you very much.
And lots of other comments said I'll give a shout out to Leo OK2UUJ. Many thanks for all your jobs and work, Tom. And not a question, Tom. This is from Mike Willis. Sorry, not a question. I'll try and replicate the tool chain if I get a chance. So there we are, acting in the true collaborative spirit of which this hobby is. Tom, we want to thank you very, very much indeed for, well, obviously all of your projects, your presentation this morning, and your continued work and supporting British Amateur Television Club and the whole amateur television community indeed. Thank you for joining us today. Hopefully you'll be able to stay with us for some of the rest of the day as well, maybe on the Zoom call over lunchtime as well, which is an informal session. But once again, on behalf of everybody, Tom, ZR6, TJ, thanks very much indeed.
Thank you very much, and enjoy it. I'm looking forward to the rest of the conference, so I'll definitely be sticking around.
Lovely.
Thanks, everybody.
Thank you, Tom.
Thank you. Bye-bye.
Bye-bye. There we are. So we've just got about 9 minutes or so before our next presentation, which is Dave, G8GKQ, on Portsdown developments. So just time to make a coffee. We'll see you again in about 9 minutes' time. Welcome back. Now, our next presenter, Dave G8GKQ, probably needs very little introduction. Dave has led the BATC Portsdown project for 6 years, and today he's going to describe the latest developments and give us a glimpse of the plans for the future. As before, please feel free to ask questions or make comments on BATC or Zoom messaging. Welcome to CAT22, Dave.
Thank you very much, David, and thank you for hosting.
Pleasure.
Okay. Right, let's crack on. I'm not sure quite how I can follow Tom. I was really impressed with that. Let's talk about Portsdown anyway. What we're going to look at is, first of all, I'll have a quick talk about the project status, look at the new features I've done in the last year, future upgrades, Raspberry Pi availability, this is a big issue at the moment, and then talk about next generation Portsdown, where we think we're going to go. Okay, the status, still very much active. Portsdown 2020, I know there's been some sort of worry, is Portsdown 2020 going to get ditched? But no, we're going to continue to support it. I think one of the most practical reasons we're going to continue to support it is there are 5 of them in my shack. I had a quick count around. For my QO100 transmissions on Thursday night go through a Portsdown 2020. I'm just rebuilding the Portsdown 2020 test and development rig, so very much continued support on that. However, all the development effort is being concentrated on the Portsdown 4. The 4 is limited in scope by hardware, but not as much as the Portsdown 2020, which is why all the development efforts going there. Looking at new video sources when they are worthwhile, looking at more test equipment, and being able to do more things with the touchscreen, and I'll talk about all 3 of those today. So here we are. This is my current Portsdown 2020 test rig. Going in a die-cast box. It's been languishing on the bench, loose for ages. It's going on the lid of the box, so I can program SD cards easily. New features during the last year, we've put in band viewer for the band viewer facility for Lime, RTL SDR, and AirSpire. All 3 of those are implemented in there, and I'll talk a bit more about those in a minute. DVB-T transmit is available from the Lime on the Portsdown 2020. And of course, the Portsdown filter modulator board is great for a cheap DVB-S wide bandwidth option. So if you have a local repeater that needs 1 megasymbol input, or God forbid 4.2 megasymbol input, the Portsdown filter modulator will do that from a Raspberry Pi 3. Gradually, I think we're going to change the name of Portsdown 2020 to Portsdown 3. To link with the Raspberry Pi 3 and to emphasize that it isn't stuck in 2020, it is moving on. Portsdown 4, to some extent, we're up against hardware limitations here. They were some were my design decisions. Some were the fact that the Raspberry Pi 4 has only got an H.264 encoder. We thought it was brilliant 5-6 years ago. Now beginning to be overtaken on other platforms. As the design decisions, we went with an 8 with a certain size of touchscreen. We've gone up to 800 by 480 pixels. And actually Tom mentioned how difficult it was to do things on an Android phone. We hit the same problems here. I've shied away from using keyboard and mouse because I really want it to be a portable setup. So we're sticking with that. So aiming to exploit the existing design. And one of the things that shows how far this can be stretched is Langston. Same hardware, just put in a little twiddly knob based on a mouse, and you get far more functionality. So video sources. HDMI capture has always been a bit difficult. On eBay, you will find lots of HDMI capture devices. They all work differently. Most of them work with Windows because they've been designed to work with Windows. They haven't been designed to work with bare metal Linux. So I have to write a driver, or at least configure an existing driver for each of them. So what we've gone with is the Elgato Camlink that you see there. Available on eBay, not on eBay, sorry, on Amazon for about 99 quid when it's on offer. So it is expensive, but it is good. It will capture 4K if you have a suitable PC to do things with 4K. On a Portsdown, it'll capture 720p HDMI very nicely. So we've added that as a video source, and that's particularly aimed at the Portsdown repeater transmitter. Another video source that came along during the era on the right there is the Polycom Eagle Eye mini USB camera. These were available on eBay at one stage for about £15. Very nice cameras, very high definition, and work well now with Portsdown 4. Lastly, people have been asking me for a long time to have selectable test cards or custom test cards. You remember the original Portsdown just had test card F. Well, I've now put a whole page full of test cards to select. You've got CE, if you really want it, 5544, color bars, a grayscale, and you can put in your own cards there. And you can actually put in 3 versions, a 4x3 version, a 16:9 version, and a 1080p version there. And it will automatically select the right version depending on what format you have selected. So you can select test cards on menu 3 there. You need to use some sort of file manager to get the test cards onto the Raspberry Pi, and that really is a connect it to a PC type activity. But it is now possible then to select them from the touchscreen while you're out portable. On the test equipment side, I'm really in awe of the work that Tom has done, and also Phil, Heather, and Tim. You know, we really are building on a lot of their work. Many of you have seen Band Viewer. I've talked about it a lot. It is brilliant for portable operation. It's transformed the way I do portable operation. This particular view here, you can see here, is the band viewer using an AirSpy. You can see it's 10 meg wide, and guess what? It's looking at the QO100 transponder there. Tom mentioned Phil's code. Band viewer actually uses Phil's code, and it all started from Phil's AirSpy code. I adapted it to the Lime, then readapted it so it works with AirSpy and RTL SDR. I am looking at adding to the list of SDRs that it supports, but it all takes time. So using the same technology as is in Band Viewer, I built up the noise figure meter. Now this was described at length in CAT22, but is really useful for checking how good your ATV receivers and preamps are. Just stick the noise figure meter with a Lime. Unfortunately, it only supports Lime SDR because there's quite a lot to do. Stick that on the IF of your transverter or after your preamp, and with a calibrated noise source, measure the noise figure and optimize it, of course. The Portsdown signal generator has been in there for 3 or 4 years now, and I've gradually been adding to the signal sources that it'll work with. But nothing went below 50 megs. which was a challenge for me because I didn't have anything in the shack to do any signal generation below 50 megs. Never been a great fan of signal generators, not used them very much, not had one, so I've always worked around it. However, I was taking apart some old kit for salvaging connectors and all the like you do, and I found an analog to devices AD9850 on a bit of PCB. I thought, that is a direct digital synthesizer. I could drive that from Portsdown, and that's exactly what I've done. So this not very neat bit here is the PCB offcut with a TCXO. That's 120 meg TCXO on the left-hand side there. Thanks, Mike. Driven by a little regulator, powered by a little regulator. On the left-hand side there, on the soldered to pin header, sacrilege, there are the SPI connections to the Raspberry Pi, and on the right-hand side there, you get the signal out. Now I'm going to put that in a box. It still isn't in a box, but it does work. And you can just select that as a signal source on the Portsdown signal generator and go from 50 megs down to 1 hertz. So that's expanding all the time. XY display, I had, or I still do have, an HP 141T spectrum analyzer, but the tube was certainly had seen better days. So using a couple of A to D converters, got essentially a storage display for the spectrum analyzer, and I still use that on my more recent HP spectrum analyzer, mainly for capturing screenshots because it produces a great screenshot. Still working on increasing the test equipment. One of the things I have in mind is some sort of microwave aerial gain comparison, so you can build your own antenna range. I haven't done any of the software for this, but the concept is you set up a remote DVB-S transmitter, probably about 500 meters away. And you look at that on band viewer and you see the signal, and you also measure the noise sort of a meg away from it, and you compare the two. So that will be coming soon. The other thing I am currently working on is a little multimeter display and logger. So these Parkside multimeters were available for $9.99, I think it was, or $11.99 from Lidl. They're easily modified for RS-232 output, and I've now successfully interfaced that to the Portsdown. Either it'll be, you'll be able to select whether you have large numbers, so rather than craning your head towards the LCD, you can have the large numbers on the screen, or a moving meter type display, or a long duration logger, the sort of thing you'd use for checking battery capacity over 10 hours and just get a plot of the voltage of a battery over 10 hours, that sort of thing. So that's under development. On the touch screen, I mentioned that we've limited the screen space to 800 by 480. In the Portsdown 4, we only support use of the display serial interface. That's the ribbon cable interface on the Raspberry Pi 4. The DF Robot market a 5-inch screen that uses the same interface and is broadly compatible. Not quite. The way it handles touch is slightly different, and I have modified the code to improve that. But DF Robot 5-inch screen is supported, and although I don't have one, and hence it's not formally supported because I can't test any changes, I am told that WaveShare do a 3.5-inch screen if you really want to make your Portsdown 4 miniaturized, which uses that interface as well. 800 by 480 is the key thing. You need to have that screen size. So more touchscreens, and the photo there with a rather dim screen, it doesn't look that dim in real life, is a die-cast box version of Portsdown that I am working on. It's not populated with all the connectors yet, but it does function. So it's a smaller version of Portsdown 4. People have been asking for web access of Portsdown, and this really is the same sort of work that Tom has been doing, you know, being able to access your Portsdown over the network. And yet again, thanks to Phil, I've been able to implement this. He sorted out the web server side of life for me, and the coding on the web side, and I just hooked it back into Portsdown. So you can now remotely control over your own network the Portsdown, switch it to transmit. You can monitor the receiver MER. You can also control the signal generator over the web. You will eventually be able to do band viewer display, probably not control. The reason for that is I want to maintain compatibility between the band viewer application between Portsdown 2020 and Portsdown 4. So I have a single application to support. And of course, Portsdown 2020 does not do web access. But at least you'll be able to watch the display having set it up. One limitation of this is there are no moving pictures. We don't do moving pictures on this. It's just a simple point and click interface rather than a full control like Tom's managed. Okay, so how do you do web control? I've only done publicized this in CAT22. I realize I haven't yet even put it on the wiki. Basically, you just, if you go to menu 2 info on your Portsdown screen, you'll see what IP address your Portsdown is on. You need to type that IP address into your browser, as you can see here. You'll get a screen like this. If you go to snaps, you just get a folder view of all the snaps that are in the folder. So you can then pull those up easily from a PC. But if you click on touchscreen, you'll see this. You'll see web control not enabled. So the thing to do is go into menu 3, system config, and press enable web control. It's also possible to do it from the SSH console menu if you want to go down that route. Okay, and now I'm going to go into a shortly going to go into a demo of that. Let's go into the demo of web control now. I'm just going to change the screen sharing, and let's go to the right screen, which is, I've lost it here. Stand by. That's the one. Share. I hope that is it. There we go. That works. Can you see that, David? Just confirm you're seeing that. Yes, yeah, you are.
That's fine. That's fine.
Good. Okay. So while I'm here, you'll see that my mouse moving across there. You can go through the menus. You'll notice it. Well, you won't notice, but there is some slight delay there. The screen only refreshes once a second, so you need to be patient. Go through things slowly, because if you click too fast, your clicks will get ahead of what you're seeing. I was talking about enabling Wi-Fi config, system config, sorry, enabling web control, system config, web control enabled, you'll see there. So that's how that is done. Let's go back to look at some of the new facilities that I put on the touchscreen here. First is Wi-Fi setup. If you go to menu 3 and Wi-Fi config, you get this screen here. First thing is you need to enable the Wi-Fi. Let's try enabling the Wi-Fi. It does that, And then these buttons on the left-hand side enable you to list the Wi-Fi networks. And there you can see all my local Wi-Fi networks. So you can see what's there from Wi-Fi. Using these other buttons, you can set up a Wi-Fi network. I won't do that because it might ruin the rest of my demo, but it's fairly straightforward to set up one of those Wi-Fi networks there. And you can disable Wi-Fi, or you can delete all the Wi-Fi information there. You can only connect to one Wi-Fi network at a time, and you can only connect to the networks you can see. You can't connect to hidden networks. Let's just disable that and we'll move on with the rest of the demo. The other thing I've done is added a file menu. This is on menu 2 because that was the only place I had space for it. So you go into the file menu here. In the file menu, there you can see there is space for a few more things. The first thing that's worth looking at is list USB devices. On here, you can see all the USB devices connected. This particular Portsdown has a Pluto, so that is what the analog devices Inc. is there. The FTDI there is a mini tuner. The KY Systems Corp is the mouse for my Langston, the sort of rotary encoder for the mouse. But the main reason I put this here is you can tell whether you have a Fushikai USB detector, USB video dongle connected, or whether you've got a cheap imitation. So if you're going around a rally and looking for a real Fushikai EasyCap, you can just plug it in to this and have a look at what it is. Now you'll notice this interface is a new interface for the Portsdown list. Is a new list interface where you can list up to 10 pages of 10 lines of information. And that has enabled me to do some file stuff, in that you now have a file explorer. So if you want to look at what's on your Raspberry Pi, this is the /home/pi directory. This one is full of rubbish because it's my development Raspberry Pi. But if we go into the next page, you'll eventually get to RPI DATV, which is the main directory for Portsdown. Select that, you see it highlights, select, and then you're into all the normal things that would be on a Portsdown. If we go into scripts here, select, eventually in this lot here, you can see there's again loads of rubbish. All the scripts that do things, but what I want to show is here, Portsdown config. If you now click on that and select it, it'll actually explore the Portsdown config file and give you a text file listing so you can see all the settings. So it's actually a real file explorer. It will also display JPEGs and play movies from File Explorer. So that enables you to do a few more things while away from your PC. Let's exit from that. Exit out of the file menu, and we're back to the familiar normal screen menu. Right, I'm going to change screen sharing again, and back to the camera, standby. Back to the presentation.
And while you do that, Dave, just a reminder to everybody at home that you can ask questions and make comments on either BATC Streamer or on the Zoom call, and we'll read as many as we can to Dave at the end. And plus, by the way, after this as well, we do have an informal session with Q&As on the Portsdown and ride and other things as well.
Thanks. And has that come up now, David? Have I got the right screen?
No, I don't think so, actually.
Let's have a look.
We've got your presenter screen, I believe, actually. So we're
right.
seeing both views.
We'll have that one then.
Okay, that's fine. Yep, we'll
Good.
bring you that.
Okay, right. More new facilities. We've been working on a Portsdown 4 repeater transmitter. Trying to make things easy for repeater groups to transition away from DTX1 or SR systems. I know some of the DTX1s are getting a bit long in the tooth now. And looking at 3 options. The initial being easy cap input. You can configure it either for 4x3 or 16x9, but normal video input. So this is take out a DTX1 and put in a Portsdown 4 repeater transmitter with an easy cap and a lime, and gives you about 1 milliwatt out at your output frequency. And this will run 24/7. Reboots twice a day for reliability, but will do the standard transmission. Now, clearly, we're wanting to move on to into the digital age and all digital repeaters. So that Elgato HDMI dongle I mentioned, that you can use that instead of the EasyCap, and you can get H.264 encoding of 720p using a Portsdown 4. And that will bring your repeater into the digital age just by swapping that out from the EasyCap. I'd have liked to make it do 1080p, but as I said, the Portsdown 4 beginning to show its age and not really up to encoding that in H.264. So you can actually swap out the Portsdown 4 for a Jetson Nano using the same Lime SDR, the same Elgato HDMI dongle, and that, once I've finished it, will transmit H.265 1080p on a 1 mega symbol signal very, very well. It would even do it on 333 if you need to. I have had it running on the bench. The problem is I can't get it to run unattended operation reliably at the moment, or I can't get it to start unattended operation reliably. Once it's started, it's fine. There's some user permissions issues, and I feel I may have to reach out to my son to help me with that one. So that's where we're going with Portsdown 4 repeater transmitters. Moving into the slightly wider world, people have had problems finding Raspberry Pis. Now, I've been tracking this fairly closely, as you'd expect. Raspberry Pi availability, I think, is slated to improve in Q2 of 2023. So April 2023, everybody's saying that things will get better. Now, clearly, there is a bow wave of demand. In the interim, I'm told you can go to the Raspberry Pi shop in Cambridge and buy one off over the counter just like that. And there is next weekend, if you feel like a trip to London, there is a Raspberry Pi pop-up shop in London where they will sell one Raspberry Pi 4 to each customer, but only one. So that's another alternative. One thing I'm signed up for is rpilocator.com. This is a website that tracks where Raspberry Pis are available. You can sign up for an RSS feed from this, and also you can follow them on Twitter, RPI Locator. And when Raspberry Pis are available, you get a stock alert of where they are. So far, sadly, all the stock alerts have been in Germany, Belgium, Australia, USA. I would encourage you not to buy from eBay. You are just putting money in the hands of people who are trying to profit from the Raspberry Pi Foundation and making the situation worse. So please just be patient and look at what's available from the official sources. And remember, some things, as Tom said, you can use a Raspberry Pi 3, 4, or even the old Raspberry Pi 2 that you've got on the shelf. Rumours about a Raspberry Pi 5, nothing doing at the moment. I think the Raspberry Pi Foundation have mentioned that their resources have been diverted during the chip shortage in trying to check out alternate sources for a Raspberry Pi 5. Obviously, we'd like it to sort of have the video encoding facilities of a Jetson, but nothing seen yet on that front. So I'm actually looking at Portsdown 4 next generation. Now, the Portsdown 4 uses the Buster operating system. Now, this is one operating system ago. But when they moved from the Buster to the latest operating system, which is Bullseye, they disabled or upgraded and disabled a number of features. One of which was the way that the Portsdown does H.264 encoding. So we decided to stick with Buster, the old operating system. Now, we weren't alone in being upset by the fact that they'd sort of moved, sunsetted, I think probably is the word, a number of features. To the extent that the Raspberry Pi Foundation have recognized this, and they actually support with security updates the old Buster version, and they call it Legacy Buster, and we are using that and we'll continue to use that. However, Bullseye brings new encoding methods into FFmpeg, for example, and maybe even GStreamer, and we may be able to use those to replace the H.264 encoding that we've been using right from the start on the Portsdown. The other thing I'm very, very conscious of is that the Portsdown software needs tidying. I would not have started from here if I'd known where I was going, if you know what I mean. And there are many aspects of the Portsdown software that I've learned along the way. I did that wrong, but actually tidying up is more risk than leaving it as it is. So when I do Portsdown 4 next generation, it will start with very few capabilities, but they'll be neatly implemented. So it really needs doing, and that's what I hope to do with when we move to the next generation. In the meantime, though, Portsdown 4 works really well, and to the extent that going out portable, I no longer take a PC, I just take Portsdowns. And I think Noel is the same. So that's the way it goes. Okay, that concludes what I have to say formally, but I'm more than happy to take questions, and we'll then transition into a wider question and answer session about Portsdown ride and generally the way things are going on digital ATV. Thank you very much.
Thank you very much, Dave. And as you say, fairly shortly, in about 10 minutes or so, we'll be having a group discussion with both you as well as Noel and Tim on this, but it doesn't stop you entering any questions now, particularly if you've got anything particular about what Dave has said. A couple of comments come in. I think some of them might be dealt with actually on our more wide Q&A session, so I might ignore a couple, forgive me, but they will be used then, or another opportunity for you to ask them then. Dave says you've mentioned being able to add extra JPEG test cards. Is there any chance of GIF support? Would be handy for animated test cards. Possibly GIF, I'm guessing that might be GIF as opposed to GIF. But I might be wrong.
It's not something I have looked at, and it's not something that's easily done. That's probably why I haven't looked at it. I will add that to the list, but yeah, play out of it will more be in the category of play out of movies by VLC, and that's probably how I would choose to do it. But I will add that to the list, but it's a way off.
Okay, and thanks. And Dave has a second question. The web access is brilliant. Any chance of it working headless, in other words, screenless?
Yes, that is already on the list. It's fairly high on the list, but I got distracted by other things. So yes, that will working screenless would clearly be a really good capability.
Okay, thank you. So I'm just trying to filter some of these because I know that Noel has said they'll be addressed more fully, probably as a Q&A in a little while. Justin G8YTZ's made a few comments there. He personally blames you, I think, completely for the pie shortage, but you haven't had that many, have you? Can I just add a little twopenneth as well for that? If you find it difficult to get the raw board, whilst I agree with you 100% that none of us should try and make the people that profit from selling them on eBay, etc., by buying them, you can also buy them sometimes as part of their personal computer kit, which comes in a keyboard with a nice breakout board, and it's genuine product then at a reasonable price. I think last time I had to do that to get a Raspberry Pi 4, and it was about £75, but with a rather nice keyboard. Would you agree with that?
Absolutely, it's a very good point. And in fact, 2 days ago, Raspberry Pi kits, I think they were 4 GB, were available from a seller. I nearly bought one and then thought, no, actually, that's just greedy because I don't need one. But they were available in UK from local seller here. I'm trying to remember their name now.
Might be CPC, was it?
No, it was the one based in Middle Wallop, just down the road from me. I'm trying to remember their name, but yes, that is well worth looking out for.
Yeah, I'm sure a lot of people have Pi Shop, Pyroni, and all those sort of companies, but it is worth looking at those because they're genuine products. You are paying a bit more, but then you're getting more for it. And the breakout board I've found personally really quite useful. That is all built into that to bring out the connectors and things to the back of the keyboard. Just a thought anyway. Justin says, Dave, is the AirSpy Mini suitable because it's half the price?
I doubt whether it would work straight away. How much modification it would need to make it work, I'm not sure. The problem is I don't have one, and I will only commit to supporting kit that I have, because otherwise I break things and people get upset.
Okay, thank you. Dave M5TXJ on BATC's just said that Pimoroni had kits a week ago. That was the kit, I think, including the personal computer keyboard. So if you're desperate for a Raspberry Pi and you don't want to feed the pockets of the profiteers, then this would be just another way. Terry G1LPS says, any news on the band viewer waterfall as mentioned in CQTV?
I'm glad you mentioned that, Terry. I put that in there as a, is anybody interested in this? And nobody was interested. So up until your comment now, nobody has come back to me. So I put it on the back burner. That's one person who's interested, so that moves it up the to-do list a bit. But yeah, there's no reason why it shouldn't get in there eventually. It's just a matter of time and priorities.
Okay, thank you, Dave. Justin says the SR Systems HD mod TX and encoder costs $500. So yes, I agree the Lime is a bit pricey. And I love the web interface. When I was testing the 70 centimeters receiver at GB3JV, I could remotely control my transmitter at home using my iPhone.
Yeah, that's an amazing capability. And Justin brings up the issue of cost of SDRs. The global chip shortage has hit us really hard. Lime SDR have had to go to more expensive components to bring out the new version of the Lime, which was due to be available this month. Sadly, I haven't seen anything. It's all gone quiet over there, as they say. And Pluto availability is another problem. So sadly, there is nothing we can do about it. But and I know people have been looking at would Caribou Light, which is another SDR being slated for the Raspberry Pi 4. Would that be a solution? And again, they have just slipped their shipping date by 2 or 3 months. So we are conscious that Lime SDRs are expensive / unavailable. Plutos are getting expensive / unavailable. nothing we can do about it. And that's why I actually said, filter modulator board, don't throw them all away yet.
Probably a great way as well as using the BATC forum if you do see a source of these, because in global scale, probably what our club members need is a small number. So if somebody does see something like this available, or the Raspberry Pis or whatever, it's a good use of the club forum, isn't it, to let other people know?
Absolutely, and in the early days of the Raspberry Pi 4 shortage, the forum was good. I'm not sure it's quite quick enough now, because they do tend to sell out. It's about 20 minutes, the life of 100 Raspberry Pi 4s on the website now.
Goodness, right. Okay. So I'm just filtering through some of these because I know that you're going to cover other things later on. I might even include some of those. I did just see a question about Wi-Fi. Yeah, from Nigel2E0EHH, excuse me, says, do you need to go through the Wi-Fi network instead of cable network to do the same on a Raspberry Pi 4? Or P4, no, sorry, on a P4, beg your pardon, a Portsdown 4.
You can use either the cable or the Wi-Fi network for web control of the Raspberry Pi, Nigel. One thing I didn't mention when I was talking about enabling the Wi-Fi is some people have found that the Wi-Fi then gets back into their microphone input, with polyscreen / decoupled microphone leads into cheap dongles. You get Wi-Fi interference on your transmission audio, just like you do with say a mobile phone at a presentation. But once you've enabled the Wi-Fi, it works exactly the same way as the wired network. But do be careful, of course, if you're only on 2.4 gigs Wi-Fi and you start transmitting on QO100, because you might not be able to stop because your Wi-Fi will die.
Absolutely. Dave, I'm going to leave the questions there. I know some of you have asked questions and they haven't been answered yet, but I'm going to bring them over to the very next session because Dave's going to be joined by Tim MW0RUD and Noel GTZ in just a few minutes' time, just over 3 minutes, in fact. So if you'll give us a moment to do that, and we'll be back with you shortly. Thank you. Thanks very much, by the way, Dave, for your talk and presentation. And indeed, thank you for everything you've done under your chairmanship of the BATC for the last few years as well.
Thanks, David. It's been great fun.
Thank you. We'll see you soon. welcome back. We've now got 3 colleagues going to join us to talk more about the Portsdown with an informal Q&A and also about Ride, or I guess anything else almost that these guys can do. So it's great to welcome back Dave, G8GKQ, as well as Noel, G8GTZ, and Tim, MW0RUD. Good morning, everybody.
Morning.
Morning.
So we've got a few things, and I promised a minute ago that we would cover some of the questions that we didn't finish in Dave's talk. I'll start with Tom. I'm not sure of your call or surname, Tom, but you said, since Portsdown uses mini tuner hardware for reception and the lifespan of the current available tuner module seems to be at their end, is there any plans for future reception projects? So who's going to take that?
Okay, I'll pick this one up. So, as Tom rightly said, I think we've not made any secret of the fact that the CERET 4473 tuner that we use on the mini tuner board is end of life at CERET. And we were given the opportunity to buy the quantity at the end of last year, and we did buy 400. We're gradually working our way through them in the shop. And my first appeal would be to the 150 people that are watching, please don't hoard them. If you've got more than 3 mini tuners on the shelf, you've probably got too many, because basically you're making them not available for other members of the ATV community. So that would be my first plea. Why would anybody need more than that? They're incredibly reliable, so we don't think we're going to see any failures. And so we would encourage people not to hoard them. We've got a couple of hundred left in the shop, but after that, we need another solution. And we have, to use that horrible phrase, reached out to the ATV community to see if people will develop or, are happy to look at developing. The problem we've got is finding a NIM or a tuner that we can work on. The great thing about the CERET tuner is that it uses a certain chipset whose registers are programmable, and it can do low symbol rates. The difficulty is finding another NIM or tuner with silicon in it that enables that, and generally just looking at the data sheet on a tuner doesn't really cut it. The problem we've got is, of course, we're trying to use it out of specification. The DVB-S2 specification only goes down to 1 megasymbol, and so manufacturers are not really in. There's no onus on the manufacturers to do lower than 1 megasymbol. So we are aware of the problem. We're putting effort in to try and resolve the problem, but we don't have an answer yet. There was Dave and I were talking the other night. Actually, there was a tuner or a set-top box that some of our community found. I think the Bristol area people probably found it, and we believe that would go down to 500 kilosymbols. We'd be quite interested in seeing a copy of that box to see if we can identify what the silicon is in its side. So that's where we are. We do have adequate stocks as long as people aren't hoarding them, and the reliability has been 100%. So we don't see a need to really replace them in the future, but we just need support from everybody to try and find a new solution going forward. So, that's as good an answer as we've got at the moment.
Kind of a similar question, but to do with the actual computers and the shortages of Raspberry Pis rather than the tuners. Mike Willis has said, might seem like a silly question, but why not move towards a low power Linux PC, small form factor, in place of the Pi for future development? I recognise power consumption is likely to be higher and the lack of GPIO would need a solution as well. Any thoughts on that? Tim, maybe?
Well, from a Ride perspective, they're fairly dependent.
We're going to bring you up in a moment. Sorry, there we go. Oh, we've lost Tim, I think, actually, off the call. Sorry about that. I don't know whether either of you, Dave or Noel, can you help on that? As a just looking at the idea of moving away from the Raspberry Pi, is that something that's realistic, or because the Raspberry Pi hopefully will come online next year, it's not so much?
It's certainly realistic. The problem is supporting many hardware platforms. The great thing about a Raspberry Pi is we know what we're getting and we know what we're trying to support. RIDE software and Portsdown software will work on a smaller Linux PC, but then the moment you start looking at peripherals like controlling PTT, using an infrared remote control and so on, you get into this great world of unknowns in that everybody's got a different solution. So and Tom has proved how portable a lot of the software is from one platform to another, but you just need that extra little bit of knowledge to change the software, recompile it, and make it work on the new platform. So its supportability is really the key problem there, but there is no reason why, if we could find a new Linux platform that we knew was going to be available and supported for the next 5 years, we could move to it. But actually, isn't that a Raspberry Pi?
Yeah, indeed. And as you said in your talk, Dave, then the Raspberry Pi, it's a well, as temporary as any of these things can be in terms of the chip shortage, but it does look like there'll be more available next year. So that may not be so much of a problem. Thanks for that. Over on BATC now, HS1JAN says, "Hi Dave, I used Lime SDR Mini V1 with Raspberry Pi 3 with Portsdown software, but I have a problem to have Portsdown software not play the .ts file to bring the video. I use HD converter to convert MP4 to TS. It has HD 1080p conversion and SD 720p, but it doesn't work on Portsdown. Any ideas?"
Right, the playing TS files, when it works, it works. When it doesn't work, it's very difficult to find out why. But generally, the problem is a TS file has to be the right bit rate. So we've got this sort of set bit rate that you can fit in your video signal. For 333 kilosymbols, it's about 440 kilobits per second. So first of all, the TS file has to play out at that rate. Then the TS file has to have the right metadata in it. So it has to have all the metadata about each component of the stream. And I suspect your particular problem is that your encoding software doesn't put the right metadata in. The thing to do as a test is to generate a TS file from a Portsdown, record it. Now, I know that's not easy. The way to do it is to take a TS stream, run it over UDP, record it, and then replay it back and see whether you can replay your own TS file. Or possibly a TS file you get off air. You can record TS files using Minitune, and they play back okay. So start with a TS file that you know that works, and then try and replicate that in your own TS file recorder.
Okay, Dave, thank you. Sorry, we're just looking at some of those. There's lots of questions coming in, which is great. I remember BATC or Zoom messaging will get them to us. Rob.au, so I guess that means you're in Australia, Rob. You said, "Although Portsdown is a wonderful solution, which is great all-round tool set, Raspberry Pis have been proven difficult to source, and Jets and Nanos are expensive. PC and laptop hardware are so plentiful, and I'm sure that most stations have a spare machine. Is there any consideration of Portsdown on PC using Linux for at least transmitting? Elgato Camlink should also work better on a PC hardware." And I guess that's really more or less what you've just answered regarding the Linux. Sorry, that just came in, and I
will come in with one comment there. On the transmit side, there is now DATV Easy, which you'll hear about from Benno this afternoon, as a way of transmitting using a PC. And there is a very good solution there. We're using an Elgato HDMI capture into OBS, into DATV Easy, and that provides a Windows-based solution. So that is there. And we are just doing some initial scoping work on perhaps a better receive solution for a PC than Minitune software. So we're looking at whether there are alternatives there for a PC-based solution. So, yep, we're exploring all these options and trying to make things easy.
Thanks. I'm not sure if this is going to help with any availability issues, but it's another suggestion about looking at different code. This time from Rob, VK3EHT, who says, have you thought about coding in Rust? The new C and C++ adds benefits on security and memory optimization.
I have thought about it. Security is not too much of an issue we see, because we rely on the operating system and the fact that we are not exposed to the internet for our security. Security in the software applications are open to the LAN. That is the principle of Portsdown. And my trouble is it's a new language, and old dog and new tricks comes to mind.
Totally understand. Well, it's another shout out for the community though, of course, because although suggestions I'm sure are welcome, help is as welcome, if not more so. So, if you can help with any of these projects, I know that Dave and the whole team, Noel and Tim, who I'm afraid we still haven't got back, I'm not quite sure, I think he might have a local problem there, and all of the team, and like Tom, always welcome and open to suggestions and offers of help as well. Lots of thanks and everything to you as well, Dave, by the way, on your previous talk. Nigel2E0EHH says, when using PD4, I connected Minitune. It does not see it when I press RX. Any idea, please?
The one thing I would suggest is go to the file menu that I demonstrated and see if you get the FTDI up listed in the USB. It sounds like a USB connection problem to me.
Okay, thank you. Right, I'm just seeing which we can take next. Nicholas Grundy, what is the minimum memory required in the Pi 4 for Winter Hill and Portsdown 4?
Portsdown 4, it is 1 gigabyte. The memory use on a Portsdown 4 is generally around 250 megabytes, somewhere in that region. So 1 gigabyte Portsdown 4s work fine. Winter Hill, I would go for one of the larger ones, but I'm not sure what the exact limit is. I don't know whether anybody else has any ideas. Somebody on the chat might actually be able to answer that for Winter Hill. I see Tim's coming back in. That's good.
Yeah, hopefully we'll be able to welcome back Tim in a moment. He's just going to make the connection. Meantime, Tom has said, I'm sorry I don't have a call sign or surname, Tom. If you can, when you go onto Zoom or BATC, if you can put either your call sign, or if you don't have one, or you'd rather not, just put your surname. It will help us to differentiate between people. Tom says, which BATC projects are in most need of software developers, keeping in mind not to step on any toes or interfere? Do you have any ideas of that? Are any of you waiting for sort of particular help on something that you'd appreciate?
Should we let Noel answer that one?
Yes, I think the answer to that is pretty much anything you feel you can contribute. We've never been known to turn people down. Dave has, I think Dave has done a marvellous job supporting the Portsdown for 6 years, and he's always open to help. I think what Tom is doing down in South Africa is amazing, because he's coming up with new ideas. We've had Phil and Heather in the background, and so it's very much a collaborative team. Everything is open. Everything is on GitHub, so you can start a fork and experiment. And if you think what you've been doing is worthy of putting in, feel free to do that. So I think the answer is everywhere. And if you've got some ideas of stuff we ought to be doing, which we hadn't thought of yet, by all means chip in. Most of the stuff we talk about, the Portsdown, the ride, we're all generated generally over a couple of pints of beer. and throwing ideas around, and we went away and refined it. And so, any ideas that you've got on your own, we're more than happy to listen to and can support through the BATC bursary project. We can fund licenses and developer platforms. And so if there's something you think that could be contributed, just let us know. And on that point, I wonder we ought to consider whether we support Tom getting an Apple app developer license. That would be something we should be looking at, and if it's a financial constraint. So no, we're open to anything, and no idea will be turned away. And I don't think there's much risk of treading on people's toes.
If I could just come in, David.
Absolutely, yes.
From my perspective, what I would welcome with open arms is somebody who comes in with a new idea for how we could make the project do something extra or better, and a concept of how it would be implemented. Not so much, not necessarily how to code it, but how it would work, and some ideas about what software would do it. So it's a broad spectrum, from writing the software, the actual code, all the way up to the idea of wouldn't it be good if. So please throw those ideas at us, and we will try and bring people into the community to try and make these things happen.
Indeed, Dave, thank you. It's all about collaboration and helping one another, isn't it? Now, Tim, by the way, you're there on our call, but you're muted and we can't see a picture. Just to let you know, update you. Oh, we can see your picture now as well. So, Tim, if you unmute as well, then we can probably hear you as well. One moment, I think he's saying. Okay, we'll come back to you in a moment. Clive Reynolds asks, could the Pluto be supported by Portsdown repeater in the future?
I've shied away from it from the point of view of reliability, because people have had reliability problems with with Pluto. We are getting to the stage where we understand those. So I think the answer to that has got to be yes. But I'm hesitating because of the reliability issues. Once I get confidence in that, the answer is yes.
Okay, thank you, Dave. Still trying to help out Tim here, but without saying, oh, Tim, you're there now, I think. And we can, we can hear you. It'd be nice to bring you in the conversation anyway, so everybody at home can see you. I'm sure everybody's aware of all the work you've done. I don't know if you've been able to hear the last 10 minutes or so to know what we've been talking about. Oh, good. Have you got anything that you'd like to add onto that? We were coming to you, I think, for answer. Is there anything you'd like to add?
The thought that when my computer crashed, I was just going to say that a lot of the ride stuff has been designed for the Raspberry Pi, but it's not beyond the realms to reconfigure it so it's not so reliant on any Linux computer will run. But yeah, it does require adjusting how the graphics works mostly, and then if people want infrared remotes and things, then obviously you've got to find some way of getting that into a computer.
Anything to add on that, Noel or Dave? Maybe they can't hear me. Can you hear me? Either of you? Dave?
Oh, yeah, we can hear you, yes.
Okay.
Yeah,
it's
we
okay.
had nothing to add.
Nothing to add. That's absolutely fine. Ian G8XZD says, there are hints on the DATV Express website that they may have a new tuner for their next generation receiver. Whether that will work, though, for BATC is another matter, but might be worth contacting Charles or Art.
Yeah, we have been talking to them on and off over the years on this, and Charles is involved in our search for the new tuner, but we haven't had anything that's a positive lead yet.
Okay, thanks, Dave. Nigel 2E0EHH says, when the Sunday WWNet is transmitting, can we stream it live on the BATC stream? Because that would be helpful, he suggests.
It just needs somebody to do it. The technology is easy. It just needs somebody to do it.
Okay, I think
there is actually a streaming channel set up already on the server for it. If somebody wants to volunteer to do it, we'll send them the stream key.
In fact, we've got an answer as well. This is a lovely thing about doing this sort of thing live. Tom, PA3FBX, says that Benno already streams on BATC for the WWNet, in fact. So I guess you'll find that under his stream, maybe, on there.
Yeah, sounds like.
Okay. Paul G6MNJ says GB3NQ uses a Pluto 12 hours a day and has proven extremely reliable at 1.5 mega MSS. Is that megacycles per second? No, mega. Anyway, maybe it's symbol bits. We also use a USB Ethernet connection to the Pluto, which again I keep hearing is a no-no, but experience has proved otherwise. Any thoughts on that?
I'm really pleased to hear, Paul, that that's proved reliable. What we have found is that the USB Ethernet connection, assuming your network is good, is more reliable. And specifically, powering the Pluto from its external power socket increases the reliability. So really pleased to hear that it's proving reliable, and I'll add that to pushing the Pluto up the priority list.
Thanks. Yeah, and actually, Mike G0LGF, in partial response to that as well, has said that Pluto has a hardware fault with a PSU. Analog know about this. Analog Devices, I guess that is the company. But it disconnects from a PC as it pleases, especially on power surges, and hopefully that's helpful. We haven't got too many other questions here, which is fine because we're coming up to our sort of an informal lunch where everybody who's on the Zoom call will be able to join, and I'll tell you a bit more about that in a moment. Another question here, though. David M0YDH comes in and says, are there any plans to include Quick Tune in Ride?
I have thought about including maybe Band Viewer, which would be a first step towards doing that kind of quick tune features, but I'm not quite sure how full quick tune, how you'd interact with it to actually select the things. Maybe if people have ideas, they can file an issue on the GitHub about how you might think you would interact and select the things. But yes, it's very. I've thought about adding the viewer, and so then people can then select them.
Okay, thanks, Tim. Just reading some of these associated with this. The Paul G6MNJ says the Pluto's on an external PSU at just under 5 volts, which I believe is the key. So keeping the voltage down, I guess. Maybe it's got either a regulator or a DC-DC converter or something like that in it, which makes that more stable. Let me see, there was another question about that in a moment ago. Dave M5TXJ on BATC says that my Pluto has been bulletproof since the diode mod. So I guess that's well publicised, is it, Dave? You're nodding your head?
Yeah, the diode mod is putting a power Schottky diode in the 5-volt supply line, which takes the supply voltage on the Pluto down to about 4.8 or 4.9 volts. I had some correspondence with Robin Getz, who was involved in the Pluto design and development. Unfortunately, he's now left Analog Devices. And he said the Pluto was designed for a power supply range of 4.5 to 5.5 volts. But the fact that the external power, the separate power socket was more reliable came out of the conversation with him. And I think probably the way to go is to power it with 4.9 volts from the external power socket, and then you get the reliability.
Yeah, that's certainly been borne out by several people commenting. Forgive me if I don't read your actual comment up, but that does seem to be consistent with what people have experienced. In fact, Paul says again after that they use a dedicated 1 gigabit switch or 1 GB switch for the network traffic, which also helps, I think. Tom ZR6TG says, I've started hacking a quick tune into Ride for myself, and I'll get in touch with you, Tim, direct. So that may help.
Yeah,
Tim, are you there?
That would be helpful.
Okay. Your video's frozen, Tim, but we've got your voice, so that's okay. Sorry about that.
Yes.
Okay.
Yeah, it should be a case of of integrating these things.
Right, thank you. So he'll be in touch with you there. Actually, David M0YDH has said that you, Dave, were having a contact with Robin Gett, so he was aware of that, I guess. Rob in Australia says, is the BATC streamer considering SRT or RIST as it's far more superior than RTMP, he says.
I can take that one. Phil, who designs the software for the streamer, has looked at some options. Nothing is suitable. We have found is suitable yet. The difficulty is integrating all the permissions management with everything else. And unfortunately, Phil has been busy on other projects recently, so it's rather nothing has been done recently apart from simple support. But as a long-term project, we are looking to migrate away from RTMP. It's just a matter of finding the right solution that we can implement and integrate with our current solution.
Thank you. Well, now thank you all three of you for joining us. We've got a few minutes left, but this is always an informal Q&A session. But now we're going to open up even more for lunch, slightly earlier than we said. Because all of you on the Zoom call with this, watching this on the Zoom call, you can now interact and be part of that in one big discussion, if you like, at lunchtime. And we'll be also restreaming this to the BATC streamer. Now, if you're a BATC member, you should have already had a link sent to you. I had got my email yesterday, and I'm sure many of you as well have. So if you'd like to join us on Zoom for that informal chat over with quite a few people actually over lunchtime, then you're more than welcome, or you can just watch it on BATC. But we'll be coming back to you in just over an hour's time, the very important talk which affects many of us who've been on 23 centimetres, because we've got Barry G4 SJH who's going to tell us about the amateur and RNSS coexistence on the 23 SEMS band. He's heavily involved with the IARU, and it's a very important talk, so I hope you'll join us for that. But meantime, I'd like to just thank Tim and to Noel and to Dave for all of your work on this session, and I guess you'll be also on this call at lunchtime, and we'll be back in just over an hour's time with that talk from Barry G4 SJH. We'll see you then. Just for everybody's benefit, if you're confused what's happening now, Noel has taken over the hosting of the big Zoom meeting, and you're welcome just to have an informal chat between you. So if you're on Zoom and you've got a camera or a microphone or both, you can switch those on now and you can have a chat between you. This is just an informal session until 1:15 BST. If you are a BATC member, you should have got an email yesterday with the Zoom ID information. But you can continue to watch on the BATC streamer when we'll be repeating this and restreaming this out on there.
Welcome to everybody on the stream.
Well, it's been fun. Thank you very much, everyone, so far. Amazing. It's the BATC or Renter Genius. Fantastic.
Welcome from Australia. Our evening, of course.
Rob, does this finish after midnight for you?
Most likely.
Oh, no.
Well, it's a good thing being a cyber member. I get to play DATV, but in Victoria here, it's not very popular. There's a few hardcore people that still do it in Melbourne, but I like to set something up in Geelong here, which is about 75 k's from Melbourne. So yeah.
Dann können wir uns gegenseitig helfen. Ah, von was redest du auf einmal? Was willst du mit dem Frauenclub? Ich will die neuen Mieterinnen mit uns Alten zusammenbringen. Integrieren, wie man so schön sagt. Wir sind doch alle Frauen. Warum sollen wir wie die Fremden nebeneinander?
No. Ja, vielen Dank für das deutsche Fernsehen dort. Hey Dave, how are you finding it?
Yeah, I'm not very good at this Zoom job, but yeah, I think I'm working my way around it now. Enjoying playing on the satellite when I get a chance. Unfortunately, I've got to go to work shortly, so I'll miss this afternoon's. I'll have to catch up on that when it comes out on YouTube.
Yeah, the video will be helpful later on, I'm sure. Hey, goedendag, chef.
Actually, I will put on a mic. Good afternoon. I'm watching you guys since this morning, and I'm also broadcasting this on our local ATV repeaters in IJsselstein and in Eindhoven.
Good afternoon to you and all your viewers then. David, are you getting on better with... last time I saw you on the net, you were struggling with freezing. Did you ever get sorted with that?
I think so. I don't come on very often because it's terrifying.
Yeah, I know the feeling well. I'm very good at, what is it they call it in the trade, corpsing?
I can talk, but it's being your own engineer at the same time.
I'm very good at, what is it they call it in the trade, corpsing?
I can talk, but it's being your own engineer at the same time. Yeah, the feedback is bad on this one.
Okay, I think we're just waiting for somebody to say something. I've come back after break. Okay, I think we're just waiting for somebody to say something. I've come back after.
Yeah, you need to go on mute except when you're going to speak. That's the problem.
Okay, I think we're just waiting for somebody to say something. I've come back after.
Okay, right. The space bar is a push to talk button on your keyboard. If you use this, you'll come off mute for the duration of your speech. Works great at work where we have 30, 40 people, and otherwise it just goes into chaos. Right.
Thank you, David.
Well done on being net controller, David.
Oh, I've tried it. Yeah. Okay. Thanks, mate. I got it.
Yeah, there we go. Yeah, because well, I do this I do this all the time at work. So
I tried it the first time. I put my camera off as well, but I've sorted it now.
I'm surprised nobody's annotated the lecture notes yet. That's doesn't that happen on Zoom usually? Yeah, we have design reviews, and you're happily talking, and then all these squiggles appear across the pictures of your solid models. In what's that doing there? Oh, wait for it.
We use Teams at work, and it's absolutely dire. It's got a mind of its own.
Yeah. So do we. Does he have any sound though?
Yeah, same in Australia. We got Teams.
Yeah, at least Zoom has crashed my computer 3 times today. So let's try a different computer.
Tim, there was a question, Tim, on the BACT chat that didn't get read out. Was the business of Ride being able to record? Did you make any progress on that?
The challenge with recording is like storing the transport stream as it comes in is relatively easy. It's just a case of I just have to sit there and intercept all the data and store it. But if you want something that's going to be able to be played back reliably, it then needs re-encoding and appropriately split so whatever's re-encoding it doesn't get upset. Because if codecs and things change, a lot of the encoding tools don't play nice. You have to split it apart and then join it back together again. So getting that to work is much, much harder. But yeah, if people just want to store the whole transport stream, then it should be relatively easy for me to add a button somewhere to make it store that. But yeah, then you have to got to put it somewhere and people have to get it off. And there's some management that needs going if you're going to make that work.
Okay, thank you. And I see Tom is volunteering to help you on or with ideas on the band viewer on Ride. I wondered whether you could actually do something like he's doing on the Android client, whereby buttons come up depending upon who's on the stream, who's on the Spectrum display. I guess that's probably what or one of the ideas he could suggest.
Yeah, it's a case of how it interacts with all the existing menus and things. Do I have to create a new menu item somewhere that you go into to? If you've got that mode enabled, is it then a menu item that lists all the current available streams, or yeah, exactly where the interaction goes? Because obviously you have to do it all through a remote control. So yeah, so it's user interface more than technology. I can work out the technology to get various SDRs and things working. I've got some GNU radio experience to make that work. But yeah, it's all about how you would interact with it. Like displaying the waterfall is easy, but I say easy, but it's reasonably easy.
I've had similar thoughts about doing band viewer on Portsdown, and again, it's its user interface. How you manage that. Sorry, doing the Spectrum view on Portsdown.
The advantage that Portsdown has is that you have a touch screen, so you can magic more buttons out of nowhere or touch points or something. Obviously, with Ride, I'm limited to the buttons on the remote, and by using too many buttons, you end up with some people can't do it because their remote doesn't have the buttons, and that so kind of burying things in the menu is kind of generally the way I kind of have to do things, but that gets ungainly quickly.
I had a thought. I don't know if I can be heard.
You're working, Justin.
Oh, okay, fantastic. I had a thought with this. that there may be an opportunity here to effectively have a single ride receiver on a repeater, and with the band viewer, it automatically selects the appropriate input as and when someone pops up on 23 or 70 or whatever. You could multiple inputs very easily with a single ride, and that could save a few pies.
But wouldn't it have to be able to receive multiple things, Justin?
No, because the band viewer would be doing that. It would look at 23 or look at 70 or whatever, and then tune the ride accordingly.
So the ride's not actually doing anything. Okay.
So your band you're going to either need either only do one band, or you're going to need a very, very expensive SDR to be able to band view if you want to be able to select between 23 and 70.
Yeah, or maybe two SDRs. I don't know. I mean, it would be it's a thought of how you could actually probably automate, or maybe you could just get to scan both bands, one then the other, and the other and the one.
You can get Ride to scan. You can get Ride to scan frequencies and symbol rates.
I didn't realise you could get it to scan different frequencies. Isn't it?
Ride won't scan different inputs and GPIO settings. That's the thing that it won't scan at the moment, because that's controlled by the ride, and it's Longmin that does the scanning. I have thought about stopping using the scanning in Longmin, and that would then re-implementing it in the main ride code.
Yeah,
would allow it to scan the inputs on it and to do the GPIO outputs. But it will be slower because it's got to reset Longmin every time that it reloads. So there'll be this dead time between scans. That's the limitation you get.
Yes, no, I understand that, but nevertheless, it might be interesting to, in terms of reducing the hardware on site, particularly if it could switch between just the scan could just switch between antenna inputs as well, because then you could potentially have two antennas in different directions, even on the same band, and do a diversity type, poor man's diversity, if you know what I mean.
I really think it would be easier to, sorry, Mike, I didn't mean to speak over you. I really think it would be easier to use just a combiner and not do filters in a combiner, because there's no reason why you can't feed 70 SEMs and 23 and 13 into one mini tuner at the same time and just let the tuner tune.
Yeah, I did go through my head and I was thinking of blocking then. But yeah, I think with the SAW filters, certainly that would.
Tom has come up with a comment on the chat, but also there was an interesting comment which, considering our audience, which is very unusual that we've got VKs on, somebody was asking, has anybody actually progressed the 10 meters DATV with 333 kilosymbols? I mean, are you guys down under doing anything looking at HF type stuff?
Not that I know of. We're still grappling, trying to get pictures at normal, like 1 meg bandwidth. But I know that VK3 RTV is actually putting a southwest directional antenna, so us people in Geelong, which is 75 kilometres towards the south, can actually participate in the ATV net that we have down here on Tuesday night. So that should be interesting. Should spark up a bit more interest, I hope.
We've practiced here in Whyalla, just across town, with 6 meters, but not anything ambitious across borders.
We were very much encouraged by the one contact from the Netherlands to Italy, which was 1,700 kilometers on 6 meters. That was 125 kilosymbols, DVB-S2. So it shows that it can be done. That was sporadic E. It can be done in these challenging propagation modes, but I would really like somebody to try 29 megs and give it a go with 125 kilosymbols.
Well, I built some kit, but there's nobody to work.
You'll have to move closer, Mike.
It's not DVB-T a better idea at 28 megs?
Can do either.
We can transmit either, but actually demodulating, when you actually try and put it on a real path, we always find DVB-S2 goes better.
Might not be the case on 10 meters though. We haven't tried it yet.
Yeah, I was thinking the multipath challenge with DVB-S S2.
Yeah, but the bandwidth's not that narrow, is it? Not that wide, rather. It's not like normal TV, 8 megahertz. It's only 500 kilohertz wide, so it's already quite narrow.
That's true. That's very true.
But if we were to do it on 20 meters, or my favourite idea would be top band, then we could get quite a lot of multipath. There's no reason we can't do it on top band, as long as we.
It's been done already. Baird did it in the 1930s.
Yeah, exactly.
Well, you'll be able to use your PL259 plugs then down there on top band, wouldn't you, ever?
Yeah. I was looking at the IC705. Noel has acquired one, and it has a 14 kilohertz, I think, IQ input, which in theory would allow us to transmit up to probably about 10 kilosymbols of high resolution DVB. So obviously 10 kilosymbols is not very much, but you could use higher order modulation perhaps with DVB-T.
That's interesting. I wonder if the 905 will have something like that. The 905 is interesting because it supports FM. Seriously considering putting an FM input into JV for that reason.
It's incredibly disappointing because it only has FM. But you never know.
I agree, but it means there'll be a lot more people with transmit capabilities. So, it could be a way of introducing them into the real world of digital TV.
Depends on the price. We'll have to find out if anyone's going to be able to afford it. It was nice to see it though. Did you come to the convention, Justin?
No, I wanted to, but it was one of those rare occasions where Julie had a stack of jobs for me, and she's looking at me sideways saying, "No, I didn't."
Well, they had one on display. I mean, it couldn't transmit or receive anything. Didn't appear to be any aerials connected to it, but it looked interesting. It's funny because the base unit is just connected via Ethernet. There's nothing in the base unit at all, and all the RF stuff is in the remote box.
I wonder if they'll bring out some software for it to be used like a Flex Maestro to 9700 and the like as well. I did suggest that to the guys from ICOM at the Dover rally.
Yeah, that's what I was thinking. I mean, it's connected via an Ethernet cable, but could it not be connected via the internet instead of an Ethernet cable? In which case you could take the head unit, put it in another country even. It wouldn't make any difference. But it might be that it relies on some other signals and it's not actually really an Ethernet cable. I don't know.
Yeah, that's what I worry. I suspect it's probably not Ethernet. They might be using PoE, but it's not really Ethernet, because I was thinking actually if I was to buy one of those, I'd put the outside unit in my loft and connect it to my network. But if it's not really Ethernet, of course you can't do that. But
yeah,
good if you could.
It is PoE. I asked him about that. It is getting the power over the Ethernet, and it doesn't need very much power because it can't transmit very much RF. So it's only 10 watts.
Yeah, well, even standard PoE does 15 watts, and PoE Plus is 30, and then PoE Plus is 60 watts.
Yeah, it's not a problem with power, I think.
So, yeah.
But I don't know if it actually has a separate supply even. It might do. And it doesn't need very much power because it can't transmit very much RF. So it's only 10 watts.
No, well, even standard PoE does 15 watts, and PoE Plus is 30, and then PoE Plus is 60 watts.
Yeah, there's not a problem with power, I think.
Who's that?
You know, if it actually has a separate supply, even it might do. And it doesn't need very much power.
I think we're stuck in a time warp.
Oh, jump to the left.
Even standard PoE does 15 watts, and PoE plus is 30, and then PoE plus is 60 watts.
Tim, going back to the ride, have I missed a bug fix, or is it due or anything for the menu for the presets disappearing off the bottom of the screen? I mean, it's no biggie, but when the remote jumps a couple of steps at a time, as it can be prone to do and sort of is known, it just can be a bit of a pain at times.
Yes, I've got a version. I've got my development version. I haven't fixed it. I've improved it. Now when it gets long enough, it bumps into the bottom and then stacks back up, so they then run off the top instead. But you get a lot more space for a lot more presets. But the thing I found with that is that because it's a full height bar sitting next to the other menu, it can get confusing about where you are in the menu. So I've got some almost some graphic design problems to solve before I can release that. That would be a good interim solution. But yeah, the ultimate solution is obviously the standard, the menu scrolling as you move around.
Just make it a horizontal menu, out sideways to the right.
That's going to have even less space.
Can't you just use a smaller font, Tim?
I could use a smaller font, but then again, how small are people's screens viewing on? But yeah, like there's various problems and solutions to them. But yeah, I've got a graphic design problem of when you've got a full height menu next to another full height menu. It's much easier to lose track of where you are in the whole menu thing. So I need to.
You need to implement some sort of ESP feature where it just tunes into the channel you want.
You need to get band viewer on Portsdown and then modify it so that it can then tell the ride what to tune to. So then you can just touch the touch screen on the band viewer and it will tune the ride to it. That's what someone needs to write.
Okay, Mike, if you haven't gone for lunch, are these lovely frequencies? This board that I've yet to populate, your frequency converter on 29 megs, is that in the club shop? Because that would certainly help things along amazingly. Back to you.
Well, that's out of focus. That's even worse. But I think that's it. I can't tell. That looks like an old model, though. Let me have a look. Yeah, you'll have to. Oh dear, what's happening?
Coming back. That's it. Yeah, it's I got it from you about a CAT21 probably. So
can you hold it up? Oh no, that might be the new version. Yeah, it looks like it is. Anyway, they're not in the shop. But what that is it's just a frequency converter with 120 meg LO, I believe, if I remember correctly. So whatever you put in there comes up 120 megahertz higher, and vice versa. And then you design the filters appropriately for the band you want. So it's a transverter, really. And it works on 10 meters. It oscillates as well. It was interesting. Dave was talking about his device for producing lower frequencies, and he hadn't put it in a box yet. And my experience with a lot of these things is that they work perfectly until you put them in the box, and then they start to oscillate.
Apologies, I appear to have become Mike Willis, which is not the intended consequence.
Now you see that's what you can do in OBS.
Excellent. I shall get round to doing 10 meters as well. I've practically built 2 4-meter stations so that we can actually have the 4-meter QSOs. So locally, that's one of the things I'll attempt. But other than that, 10 meters is another one to go for. Might be very interesting. Wonder what will happen. Will there be anybody out there? Okay, I'm going to go for a bite to eat. Thank you very much for the chat, and hopefully you'll all get on swimmingly while I'm away. Bye now.
I'll do 10 meters at some stage. I've got a KW amplifier XBOAC, which will do the job nicely, I think.
Right, folks, I'm going to have to get ready to go off to work. So thanks for everything this morning, and we'll catch up with the rest on YouTube. But yeah, catch up with you on QO100 or wherever. Take care all. 73 from me.
Cheerio, David. Nice to see you on.
Got one of these ready to go, but everyone's too close to me, unfortunately, for 10 meters.
I'll have to build 10 meters for you, Colin. I'm plenty far away.
Excellent. Excellent. Yeah, we'll have to have a go, won't we?
Did you get yours tamed, Colin? How did you get that tamed in the end?
I did. It's got I moved one of the tracks down, but it's just got lots of absorbing foam in it, really. Yeah. And that seemed to do it.
I managed to get mine tamed until I put it back into a box, and then it took off again. So
no, this one, both of them. I've built 2 of these, and this one's the original design, and yeah, it seems to be fine now, but it did take a lot of foam.
Yeah. Yes, I remember.
May I ask what bandwidth you're allowed to use on 10 meters in Britain?
Well, we get up to, was it 29.8? I think we're allowed to go up to. So in theory, you could use the whole band because it's usually very quiet when the band's not open. But then that's not really the point of going on 10. So I don't know what you'd do really. I reckon you need. I've tried it locally on 333 kilosymbols based on around 29.5. But when the band's open, it's full of American repeaters over here and that sort of thing. So it might be more difficult than we think.
See, here on 6 meters, we're allowed 500 kilohertz in our license conditions, but not on 10.
So how much have you got of 10 meters then?
I'm not in the HF brigade.
Oh, right. Okay.
The bottom end of the CB band's quite quiet.
So there is an IARU Region 1 allocation, as Martin said. I think it's on that piece above 29 megs. It's on the RSGB band plan. If you look, it's wideband digital experimental modes. So maybe region 2 and 3 ought to push to get the same allocation.
Well, that would make it easier, wouldn't it?
Precisely.
Oh, apparently I've got a sandwich, so I better go and have that. See you later. Yeah, the RSGB band plan says 29 to 29 5 10. So there's just over 500 kilohertz, and that I believe on me is an IARU region 1 allocation. So pardon me, that's why we're aiming over here.
What symbol rate do you use it? Because I think 10 meters needs DVB-T, but the knucker is rather slow in locking into the signal. So I wonder what kind of receivers you want to use for 10 meters.
So most people, there's been a transverter project. So then Mike MJW designed a transverter, so that would give you transmit and receive. But most people are using DVB-S or S2 because we found that the lock time on the Nooker receiver, the lock time is quite long, longer than the lock time on the S2 receiver. So it's only been local experimentation, though. I think the most people have worked is across the shack almost. But 50 megs has got potential, as you know, Holland down to Italy in the summer. So yeah, but it's all good experimental stuff. We perhaps ought to put something up on the forum, sort of to encourage chat about it as it's worldwide. That would be that's perhaps we ought to start a topic up there to encourage people to build common stuff.
Well, I'm planning to make a converter for the low bands like 6, 4 and 2 meters. Just converting the receive frequency up to 315 megahertz, and then using a very narrow SAW filter for used for LPD devices in the USA. They cover only about 200 or 300 kilohertz, and then you can improve the selectivity of your receiver, like the mini tuner, and also build in a kind of spectrum monitor, so you can make sure that the transmitted carrier from the other station is in the center of the frequency, like a small VFO on it. Maybe you have plans too for this kind of devices, because I know someone who uses it in contest, and he finds out that sometimes he had to move the center frequency on 2 meters just to the center to have a good reception with a mini tuner. He's now doing it with an old receiver with a spectrum viewer and 7 kilohertz wide, 70 kilohertz wide filter in it. But yeah, we have these new SAW filters, and they are rather small. So that's an idea I'm brewing on right now.
I don't know. Mike, have you got any comment? Mike MJW's built a couple of transverters for that band. I know he's on here.
What was that, Noel? I've just got back with my lunch.
We're talking about 29 megs. I mean, you built that transverter, didn't you?
Yeah, a few others built one, I think. Martin built one, and Colin's probably built 2. David's got a board but hasn't built it.
I've got mine in here in Guernsey. It works.
Yeah, Keith built one as well. Hi, Keith.
Yeah, hi, Mike. Yeah, I've got 100 watts on 10 meters if anyone wants to try. It's not connected at the moment, but is there a power limit on the DATV on 10 meters?
The problem is you've either got to be local or a long way away, mostly.
Yeah, I'm probably too close or too far.
Well, you're in between.
Yeah, that's the problem.
Skip zone, poor soul.
Also, I was listening to the New York repeater the other day on 10 meters, and although it's a good signal, when it's not really, really strong, there's quite a little phase distortion on it. So I don't know how our signals would get through, but there would have been enough signal to noise for a US to UK contact on 10 meters a couple of nights ago, easily.
Just discussions there about what Sunday lunch is going to be. So she's off to Marks and Spencer's. She says, I'll let you lot waffle about technical stuff.
Pardon you.
Yeah, new toy from China this morning. Actually, it's arrived the other day. It's the active GPS antenna, and there's a carbon fiber hole for it, and that's going to go up on the mast shortly for my Galmon monitor, that Bert Hubert's project. I've been on the Galmon monitor for a while now, and this is the new antenna for it. So hopefully, we'll more GNSS satellites.
Looks like a magic mushroom.
It does, doesn't it? It does. Yeah, well, it's a TNC socket. I've got a TNC lead for it and everything. But, I've got everything now to mount it, got the scaffolding and mount it. And also, there's significant progress on the mounting of my 1.2 meter dish on the side of the house. It's rained the last couple of days, and I need somebody else to help me maneuver it into position. And then
yeah, what? So you hold the umbrella and they maneuver.
It's almost like that.
Not
yeah,
shouting
no.
up a bit, down a bit, left a bit, right a bit.
It's quite a heavy beast actually, but I've used chemical mounts into the side of a chimney, but the dish itself isn't really in where the wind's going to go, so it shouldn't have too much wind loading on it.
The system that John had at the convention was wonderful. It's sort of like, you know, on a lathe where you have the wheels you can turn to move the cross slide, etc. That sort of arrangement, but with a tube, but very fine control. So you just plonk it roughly in the right direction, and then you accurately point it with those, and it makes it so much easier to get it properly set up. Because when you're using the standard mount, you're tightening up a bolt, you get it perfect, and then you go to tighten it up and it moves a bit. Then you have to sort of work out exactly where it will end up. So you have to slightly off point to compensate for that, and that's very difficult to do.
Like the alignment on a car. So many you tighten it up and then it's off again.
Yeah.
But no, it's I've got one of these Italian dishes, but I got it for £100 on eBay, so I was quite pleased with that. There's a guy with a caravan who had given up caravanning, and they used to take it all sorts of places to get the TV. And
how do you know it's Italian?
Oh, it's the Gibraltar or whatever make it is. Is it?
Isn't that just a Channel Master rebadged?
Oh, maybe it is.
Taken over. I think it is. Is it made of plastic or made of metal? Plastic.
It's aluminium.
Aluminium. Oh, it might be a standard one then. Yeah.
But it looks well made anyway, and really good condition and everything. So
yeah, they usually are.
Yeah, but borrowed a roof rack from a friend of mine that fits, another Tesla owner, and brought it up from Devon. I went and got it and brought it up from Devon.
I hope you put it upside down, otherwise you might have had the first Tesla helicopter or Tesla aeroplane or something.
Yeah, no, it was strapped upside down with lots of bungees, and but it got a bit noisy above 60 miles an hour, so I travel back at 60 miles an hour. So. But no, it's a nice dish. It's as I say, and I've got a great big sort of 10-inch plate mount for the side of the chimney, and 8 chemical raw bolts.
You're going to mount on a chimney.
Yeah, well, it's the chimney's on the outside of the house, but it's half built into the house, if you know what I mean. So it's
okay. Yeah, well, chimneys are usually on the outside. But...
Yeah, well, sometimes they're inside, but no, it's there's a return from the end of the, because it's near the end of the house. There's a return, and it fits in there beautifully in the return. It's exactly the right direction as well. So
yeah, as long as you're happy with a ton hanging off the side of the chimney, then it'll be okay.
It's not like that. The only thing that hangs off the side of the chimney is a little tiny bit of the dish. So
it's not the weight of the dish, Justin. It's the wind load.
The wind load.
No, it's not in the wind. That's the point. Because there's a, how can I describe it? The wall is here, and then the chimney comes out here, and there's a sort of an 18-inch return. So it's a bit like mounting it flat against the wall. And there's a tiny little bit, which no, it's not like that one. It's only a tiny little bit that protrudes to the passageway.
So it's effectively the same wind loading as it would be on the chimney anyway.
Yes. Oh, sorry, it's not on the chimney itself. Sorry, it's below the eaves. It's on the breast. Below the eaves. Sorry, I didn't mention that.
So you can't underestimate the force in 100-mile-an-hour wind. Which
No.
Is what you have to plan for.
when I built the house, I instructed the structural engineer to make sure the chimney was strong enough to take lots of aerials. So and the builder, he was smiling. There's a pumice stone inside and obviously a brick outside, and he was smiling as he dropped these rebars down the holes in the chimney.
Have you got a picture, mate?
And then he helped me put the aerials up. So there we go.
What's going to happen when someone comes to demolish it? That's going to be fun.
Oh, this house, the foundations are about 1.5 meters of stripped concrete, and the builder said, "Oh, I think I dug the foundations too deep because we needed 9 concrete lorries worth of concrete in the foundation." It's I hope they don't demolish it for a long time, actually. But
no, but you can imagine, in 100 years' time, and Time Team will be coming around and wondering what on earth was going on here.
Yeah, I imagine. I mean, when I sell this house, if I ever do, I might not. But if I sell this house, I'm going to have to say to the people with the KNX building and everything, I'll say, whatever you do, go to a KNX specialist if you need anything doing, or come to me, because your average electrician will probably destroy it. But there's plenty of KNX qualified people out there, But
There's someone at the front door.
it's I'm so pleased I went down that route, the smart building route. And I've got if you're interested, I've got a new, just wander into the kitchen, I've got a new touchscreen panel, which is actually based on Windows 10 IoT.
Can you go outside and show us the chimney?
Yeah, I can do. Yeah. I'll put the mounting plate. That's what I mean. Hopefully the Wi-Fi will. In the slippers as well. So there's the
Oh yeah.
There it is. You see that return, and so it's below the eaves. The dish will be mounted there. The holes are all drilled and the chemical mounts. You can't see them, but it's fairly low down the wall. It's actually about just above the level of the window there, the windowsill that you see there.
So it's under the eaves.
Yeah, it's under the eaves. Yeah.
Oh, I would have thought that'd be fine. It's around the corner as well. So
yeah, that's what I mean. It's you can see those aerials stayed up in the 70 plus miles an hour we had last year, without any issue.
Adjusting
and
it.
they've been up a long time actually, but yeah, those are my solar thermal roof tiles, and I've got similar for PV on the other side.
Oh, those solar ones.
Down the. Sorry.
Those are solar roof.
I'm sorry. Can you hear me still? Oh my goodness, that's a plane going across. Not sure if the Wi-Fi is making it out here.
No,
you still hear me? Oh, okay.
Thanks for showing us that. That
was... Yeah. That's you say that it's below the eave, so it should be absolutely fine. The Windows IoT panel there, that one there. It's the new one. Because it's Windows, I can actually get BATC on it. I've got VLC installed on it as well. But
wow.
you can look at the CCTV or into the main piece here. Here's the I don't know what's that was the lounge. There's the kitchen example. So they're some of the controls for the kitchen, the heating. Lounge is a good one to show because lots of controls there. And there's a scheduler where I look at. I'm doing all sorts of interesting things with the scheduler actually, including now I'm looking at predicted solar isolation to work out whether I turn the heat pump on to do the hot water overnight or whether I wait for the sun the next day if it's going to be a sunny day. And lots of sort of energy saving little things which are fun. Quite enjoy all this, building management stuff. Have you seen the? I'll show you the typical wall controller, room controller looks like this. Now that's a thermostat and a temperature sensor. In this room there are actually two because it's a large room, so there's two zones in the underfloor.
It's going to be a ride controller as well, eh?
It could be actually. There's no reason. No, absolutely. I can certainly send a webhook from those from KNX and through another. I'll show you the one in the bathroom, which is a touchscreen type This is there's a room controller in the bathroom, and what I don't know if you can see that, but what you're seeing there is exterior temperature at the bottom, the hot water temperature, which is actually taken from the average from the top and the middle sensors, core, and then the blue flashing and say the hot water is too cold to have a bath. But obviously at 39.9, it's there's enough hot water there for a couple of showers, but filling up the bath would be a challenge, you know. But it's also there's a presence sensor here, and the presence sensor switches on the mirror lights there, you know, in the bathroom. But and the other thing, you've got to go into the shower, and then you've got all the you know, all the RGB type stuff and all those programs and things you can do with that. So if I want,
can people control your house through the TV, through your ATV repeater? Then, conversely speaking,
I was just wondering about that.
do you know what? That's something else that could be done. Joking aside, there's a room controller in the bedroom here.
It's
so
not.
we'll
It's
heat
not.
him up and get him hot now. Right, quick, heat up on 20.
It's not Alexa, is it? You can't just say Alexa, turn on the light or something like that.
You can, yeah. I've interfaced that. That's fairly easy. Oh, it's nearly time. Alexa, lounge down lights on.
Okay.
There we go.
Alexa, lounge down lights off. No, it doesn't work.
It's doing a reminder as well.
Alexa, join the BATC stream.
Well, she heard that, yeah.
I'm having trouble hearing.
Try Alexa, stop. Try the lounge down lights again. Do you want to try that again?
Yeah, Alexa, turn off lounge down lights.
There you go. It worked. Yeah, that worked fine. What else can
I wonder if G4FKK has been on broadcast radio and issued an electric instruction as in a wicked moment when he's been on air.
That's the Powerball, the Tesla Powerball, and at 4 o'clock that start exporting energy to the grid. That's the it's a bit messy, my garage actually. There's the cylinder and the solar thermal and the and there's some of the zone valves. There are 11 of those around the house, and there's the flow temperature controller and the heat pump controls there.
And the PA?
The network cabinet is there. That's the network cabinet.
That Powerwall looks like it'll run a decent PA for a good 10 minutes.
Hey guys, we are just about 5 minutes from the start of proceedings, so we'll be muting you in a minute or so, and then handing back to BATC control.
That's the server that does the lots of things, but also does the GB3JV recordings stored on there and then synchronized with OneDrive. That's the Synology drive there. They're recorded locally on an SSD in the back of the ATEM, and then synchronized up to that server, then synchronized off to.
Justin, I wonder how much it all costs. That's quite a much expensive gear you've got there.
And welcome back. Our next guest is Barry G4SJH, who is the chair of the IARU Region 1 Spectrum Regulation and Liaison Committee, and is the IARU lead on the process to try and ensure coexistence between navigation systems such as Galileo and amateur transmissions in the 23 centimetre band. Following some interference cases, the ITUR has agreed an agenda item, 9.1b, for the World Radio Conference in 2023. To prepare for the conference, the ITUR has been formally studying the topic, and it's likely that some constraints on amateur operations in the band will emerge. This presentation summarises the regulatory and technical problems, identifies the expected way forward, and the likely impact for the 23 centimetre band radio amateur users going forward. And if you have any questions or comments for Barry, just pop them onto BATC or the Zoom message, and I'll read as many as we can to Barry after his presentation. But now, welcome to CAT22, Barry.
Well, thank you very much, David, and good afternoon, everybody. And thank you for the introduction there. I think you've covered most of it. So many of you hopefully will know me already as G4SJ, active in the microwave frequencies and what have you. And in addition to the work I do to help the IARU, of course, I'm also the RSGB microwave manager. But this presentation is given to you in the context of my efforts to assist the IARU principally on this topic today. And of course, secondly, thank you very much for allowing me to give the presentation today. Some of you will likely have seen this before, perhaps. I did present pretty much the same set of slides at a roundtable earlier in the year, one of the microwave group roundtables. I have presented also the slides at the Friedrichshafen ham radio event, and I also presented the same presentation pretty much at the recent EME conference, actually, in Prague in the middle of August. So, you know, it has been doing the rounds. But today, at least, you get a little bit of an update because there have been some small developments since I gave those other presentations. So what I hope to do today is to give you a feel for a number of things which are important in this discussion. First of all, I like to say something about the regulatory situation because that is a key element of the work and how the work might proceed and why we have to do what we have to do. And this will then cover the kind of particular difficulties that we find ourselves with in the band as the amateur service, trying to coexist with these other services. Sorry, my notes are down here. And we'll look at some of the study work that is taking place, because I hope that then you can get a feel for how serious the topic is being taken. And then ultimately, which is really what you want to hear, is the kind of direction of travel and what it may mean for the 23 centimeter band as we move forward. So first of all, this second slide here shows the positioning of our 23 centimeter band from 1240 to 1300 megahertz in the part of the spectrum where actually a number of the radio navigation satellite services operate. They're not just in our band, they are in bands above at 1500 megahertz. People know GPS can be found up there, for example. And they also operate in bands below the 23 centimeter band down here. And there's a number of systems. So we have principally the Galileo system shown in these blocks which have a dark blue. We have the GPS bands, L5, L2, and L1 in various parts of the spectrum, but not really in our band, although I'm told there is a small extension of the GPS spectrum here into the lower part of the 23 centimeter band. We'll see that on one of the other slides in a minute. We have the GLONASS system, which is a Russian Federation system as well. And there are some others. China has its own system. It has a system called Compass or Beidou. I think they renamed it from Beidou to Compass. Some people use the names kind of interchangeably. And Japan also has a regional system known as QZSS. So these operate across this wide range of frequencies from about 1160 right up to 1600 megahertz in these various subbands. And you can see our 23 centimeter band is here, and a number of these, or at least two here, but yeah, two to three of these subbands kind of are in the same frequency band as ourselves here. So the issue is being looked at, as we said in the introduction, in the context of the World Radio Conference. But the technical work or the studies, well, and the regulatory situation actually, are also being considered within the CEPT arena, which is the regional telecoms organization for the European region. So they've had their own work, which was kind of been running in parallel and actually started before the work in the ITUR. But now really the preparation for the World Radio Conference is now kind of dominating the work. But of course, the CEPT work will continue along at a kind of, in the background, shall I say. And that's important because not only will we have an outcome from the World Radio Conference in some way, but we will also have a regulatory outcome within the CPT region as well. And as I hope we might touch on later, we can talk about what that might mean for us in this region. So yeah, I've mentioned the systems that are within the scope of the study, and the whole purpose of the work, which is defined very formally in an ITUR resolution, is to eventually consider any technical and operational measures to be applied to the amateur services that, well, the administrations and regulators can apply to the amateur services to ensure that the radio navigation satellite services are protected. So that ultimately is the key goal of the work, and the work in the ITU started by examining all the applications and things that we have in the band, and then has gone on to do these technical studies that we'll see a little bit about later on, and eventually these studies will inform this process to decide what measures might be needed to protect the RNSS services. So just to touch on the regulatory status first of all, because this is actually at the center of why this is being studied and discussed. So the band 1240 to 1300 megahertz is allocated to the radio navigation satellite service on a primary basis across all the three regions of the world. The world is in three regions as far as the ITUR is concerned. We are in region 1, which is essentially kind of Europe and Africa. Region 2 are the Americas, and region 3 is the Asia Pacific areas. And the tables in the radio regulations of frequency allocation are split into those three regions. So you can have one service in one region and a different service in another region. You can even have a different status for the services across different regions as well. But in this case, the radio navigation satellite service has a primary allocation across all three regions. And it's not the only service that has this. Actually, in the band also, as we well know, radio location or radar systems are also a primary service within the band. We know that in the UK because we coordinate with them when we request licenses for sort of repeater installations and things like that. So the 1240 to 1300 megahertz band is allocated to the amateur service on a secondary basis, and in addition to, and that's also on a global basis across all three regions. And in addition, we have a portion 1260 to 1270 megahertz, which is also allocated by a footnote in the radio regulations. This means it's not in the direct, let me say, tables of allocations, but there is a footnote which says that in this 1260 to 1270, the amateur satellite service can also operate Earth to space direction only. But that is also effectively on a secondary basis because it shouldn't cause any interference. And this primary and secondary basis for the allocations is what is at the center of why we have this kind of problem that we are faced with today. Because if you look in the radio regulations articles, you can see at the bottom of the slide there, these are the direct articles 529 to 531. And basically, if you read those, you'll see that the secondary services have a responsibility to not cause interference to stations in a primary service, which frequencies are allocated, the same frequencies are allocated, nor can the secondary service users claim protection from harmful interference from a primary service. So, for example, we don't claim protection from interference from radars. It happens, we see it, but we we work around it, we coordinate, and so on and so forth. But actually, if there's another secondary service, then you have to respect each other, and you can claim protection from another secondary service, but that's not really what's important here. So it's really this Article 529, which is the important one here, and this sets the whole scene for why we are involved in this activity and why we have to look at these studies. And if we move to the next slide here, you start to see the scale of the problem from our perspective, having in mind this regulatory requirement that we have to not cause harmful interference to the radio navigation satellite service. So in this slide, we have so this covers 1240 to 1300 megahertz. At the top here, the blue blocks here represent the frequency ranges that are occupied by a number of the radio navigation satellite systems. So we see the Galileo block here, which is also co-frequency with the QZSS system, at a slightly different frequencies for the bottom and the top of the band, but to all intents and purposes, they are pretty much co-frequency. We see here the Chinese system in this block here. These blocks B3, E6, and L6 refer back to that previous slide I showed at the beginning. So the compass system, the Chinese system, sits here between these frequencies here, 1256 to 1280. And then here we have the Russian system, the GLONASS system, actually goes right down to 1237, so that's at the bottom of our band, but it comes up to 1255. And then there's this small piece of the GPS system that creeps in to the bottom of the band up to just under 1243 megahertz, but goes down to 1210 megahertz, which again is below our band, of course. And then below this, we have a summary of the IARU amateur service band plans that we have across the regions 1, 2, and 3. As you may be aware, we operate our amateur services on the same regional basis, shall I say, as the ITU when it comes to dealing with regulations and things like that. So regions 1, 2, and 3 are the same regions as the ITUR regions that I spoke of earlier. So we see here, for region 1, our region here that we're in today, if you look at the band plans, and there are lots of other details in here which are not included in this summary, but you can see we have ATV applications, of course you guys know, being a BATC, in 2 parts of the band. We have what we generalize as medium bandwidth modes here, here, and here. So this would refer to things like maybe FM kind of system, maybe FM repeaters, voice repeaters, this kind of thing, could be data repeaters. Then we have our narrowband modes here, which are well known, above 1296, between 1296 and 1297. This block here shows the satellite uplink block that I spoke of earlier. And then we have the similar summaries of the band plans for the other regions. And you can see from this that actually, in reality, our band plan in region 1 is, should we say, quite somewhat more developed than the band plan well, certainly in for Region 3, where there's not very so much detail defined for the use of the band in their region. So I guess people, they work on a kind of more of a national basis, I suppose. So this shows you the thing that this really tries to show is really how much of this range from 1240 to 1300 is being occupied by the radio navigation satellite service. So this is not a service which is taking a few megahertz here in the band and another few megahertz here in the band and so on, and there's lots of space in between. It's not the case. There is virtually no room in this band plan, except maybe in the middle here and maybe at the top, where there is no co-frequency radio navigation satellite system. So yeah, this is a part of the challenge that we face. Bearing in mind this responsibility we have to not cause them interference. So this leads into this slide here, which kind of also reminds us some of the additional challenges that we have for this for respecting this regulatory responsibility. As I just said, we're co-frequency with a radio navigation satellite service almost everywhere in the band. Secondly, we don't know where a radio navigation satellite service, I need a shorter expression, don't I? I could say Galileo or GPS or something. We don't know where there is a user, actively receiving and actively using the service. I mean, my phone is sitting here. That's put a GPS receiver and it's probably alive in it. Okay, I'm not actually using the service right at this minute because I know where I am, but we have no idea where there is a user who might be using the service. So, if we wanted to protect that user from interference, we wouldn't know where they were. The users of the navigation satellite systems will also most likely not be aware that they are suffering from interference. And this is important for the next point, because certainly for the Galileo service in this band, they've been very vocal in sharing their ambitions to deliver new high accuracy services in this frequency range compared to what we have perhaps available using some of the other systems. And we suspect that actually they have some commercial ambitions behind this as well. So, it's becoming quite an important part of the frequency range for them if they want to deliver these services, which, by the way, are to a large extent still under development. So yeah, so if you're paying to receive some super high accuracy service, maybe you're in construction or who knows what, and trying to work down to centimetric kind of levels, and suddenly it all goes a bit wobbly. You wouldn't know why that was, and you wouldn't know as an amateur service or anything causing that problem. So it'd be very difficult to cease the transmission. And of course, these receivers are likely to be all over the place. They could even be in cars. They could be providing autonomous driving applications, or at least helping to provide those kind of applications, all sorts of things like this. So, we have no idea where they are. So there's no way we can say, okay, I can see an installation over there, like you can with a radar, and say, right, I know that I shouldn't be transmitting before in that direction, and therefore can avoid it. We can't do that. So it's very, very difficult. So with all these problems in mind, the way the work is organized in the ITUR is that, having defined the scope of the work in this resolution that I mentioned earlier, where it talks about these technical and operational constraints, the ITU then agrees that agenda item back in 2019, and then goes through a study period. This is what it's called, actually, the study period, which is effectively the 4-year period between that WRC in 19 and the next one in 23. And in that period, the ITUR study groups carry out the studies, and the particular and relevant study groups are identified also, again, right at the process, at the start of the process, immediately after the WRC. They are given the responsibility for doing those elements that are deemed necessary in order to carry out the studies. And for this agenda item, we have two study groups in the ITUR that have been important. And I know that some people, I'm sure, on this meeting today will be familiar with the ITU structure. But there are two mainly that have been identified for this work. So we have Working Party 5A, which is where traditionally the amateur services and all issues to do with the amateur services are considered. So we have there are some ITUR deliverables that relate to the amateur service. If they need updating, modifying, or whatever, then that's 5A is where that is carried out. And we have a particular subgroup, often within the structure of that working party, that deals with all the amateur issues. So they've certainly been involved. And in fact, Working Party 5A had the lead responsibility for this agenda item, for feeding into the WRC. And there's a process for that, which I won't bore you with here. And then to support their work, because Working Party 5A is not the expert group for satellite systems, the work to actually carry out the studies against the satellite systems are carried out in another working party, Working Party 4C, as it's called, because that comes under study group 4, which deals with all the satellite services. And 4C in particular deals with the radio navigation satellite services. Again, doing all sorts of other jobs relating to those services, but one responsibility they've been given is to carry out the study to support Working Party 5A. So we've been having to participate in two working parties in the ITUR, both Working Party 4C and 5A, in order to ensure that our interests as the amateur community are properly taken on board. And Working Party 5A had the first part of the job to do, because in Working Party 5A, we were able to document and share an agreed set of technical parameters that related to the amateur services. So we looked at all the applications, including TV, of course, but also narrowband, what kind of things we do in narrowband, repeater systems, all sorts of things like that, and provided a comprehensive set of, let's say, typical operational characteristics into Working Party 4C. So this was clearly given to 5A because that's the amateur expert group. They feed that information into 4C, and then 4C uses it in its studies because they're kind of the experts who understand the radio navigation satellite systems. So what have they been doing in Working Party 4C then? Well, largely the studies have included propagation model predictions used to try and estimate the distance over which harmful interference might be seen by a terrestrial radio navigation satellite service receiver. And they can do that, or they have done that, for a range of amateur, let's say, transmitter powers, using those parameters that we propose from Working Party 5A. Now, the expression they use in ITUR is harmful interference. And the criteria that is used to determine whether a signal level received at some distance away in those receivers is harmful or not is whether it exceeds a so-called protection criteria, which is built in or documented or reported in the ITUR recommendations for that service. So actually all the radio navigation satellite systems, whether it's Galileo, GPS, GLONASS, they're all documented in the relevant recommendations that come from that study group 4. And for all those systems and for all their kind of modes of operation, which can be various, it's not a sort of a simple task really. They have these receiver levels, which they deem are the maximum level of interference or signal that the receiver could be seeing before it's deemed to be causing harm to their system. And if we look at this for the Galileo system, and I will focus a little bit on Galileo because that's probably received the most attention. We can see in the appropriate recommendation, which is ITUR M1902, that they have a protection criteria of neg 134 dBW for narrowband emissions, and they are those that are less than 128 kilohertz in bandwidth. And then they have a criteria of neg 140.5 dBW per megahertz, so a spectral density for wideband emissions deemed to be greater than 1 megahertz. So obviously you can see that as the DATC, a lot of your members would be operating systems that would fall into the wideband criteria. When I talked to the EME guys, they had a slightly different perspective on it, as you can imagine. So these are the levels which are deemed to be important to ensure that interference doesn't occur. And I need to speed up a little bit, actually. So they've been assessing these estimates from propagation models against these criteria. By the way, neg 134 dBW, I sort of estimated to be around about a kind of S1. If you're in a narrowband receiver, we would consider it about an S1 kind of signal level, actually. So it's still quite low. In addition to these propagation model estimates, they've carried out some test programs of actual measurements of amateur transmitters against radio navigation satellite system receivers. Actually, they used Galileo receivers to try and see whether there are some differences between how different modes of operation in the amateur world could impact the receivers in a different way. And then finally, they had, unfortunately for us, a couple of interference cases which are documented. One of these is historic, which also was one of the reasons this work kicked off many years ago with interference from a German TV repeater, unfortunately, into the Galileo Control Center in Germany. And another interference case that they like to continually advertise was in Italy from one repeater, FM voice repeater station, which is unfortunately very, very close to the European Commission's Joint Research Center in northern Italy. So they could very easily see the signals from this repeater. So that is kind of the three areas of the studies. If we look at the propagation model estimates, this slide gives you a little feel for the typical results that we see. If you wanted to look into the report, you would see these plots and figures in there. I don't propose to go into any of these in great detail, but just to point out some kind of interesting facts. So you can see here they were formed mainly by France, actually using the Galileo, and the Chinese folks also got in on the act with studies against their compass systems. So if we look at this plot here, for example, this sort of shows 1260 actually to 1300, because this is the Galileo range. And they've used a whole range of power levels from 1 milliwatts up to 300 watts and assessed the maximum distance that criteria I talked about could be exceeded according to the propagation model, which, by the way, is a statistical result as well. And just to draw attention to the fact that actually up here we take this top level at 300 watts. So in these areas they've assumed a narrowband system. Of course, we know that actually most of our narrowband activities take place here, but if you were to take place in the rest of the band, you can see a distance of around about, 16 kilometers. So, on main beam, something like 16 kilometers away, you could expect that perhaps one of these small receivers would see some signals. If you take the wideband case, so ATV case, for example, and you have the same power levels, then it's just slightly higher. But again, it's somewhat less than 20 kilometers. So it's not the end of the world, but it's still quite some kind of distance. So yeah, this gives you a feel for the kind of scale of the problem we're looking at. They also have results that are done with a 360-degree kind of basis around an antenna. And of course, as you could imagine, it follows a kind of antenna pattern shape. And in here you can see the red line is the way the criteria is exceeded. I think there were some slightly different criteria in the propagation model, so the distance here is slightly different. But in this case, it talks about 26 kilometers sort of on the main beam in this particular case. So you get a feel there's a lot of these results in the studies, and these are being used to make some judgment about the potential for interference. If we look at the measurement campaigns, so this is where I said they've taken some amateur equipment or maybe simulated amateur signals and thrown them into a chamber, an anechoic chamber, where there are a number of radio navigation satellite receivers. Again, naturally, these were all Galileo receivers from 3 manufacturers. And then they've thrown more signals, narrowband FM, digital signals like D-Star in this case, and also television DVB-T2 signals towards those receivers. They've moved the frequencies of the amateur signals around relative to the center frequency of the Galileo frequency block. By the way, the Galileo signal in this band across that whole 40 megahertz is a like a sine x over x kind of spectrum. I think the main lobe is about 10 megahertz wide, and then there are side lobes in that spectrum. So it does occupy the whole band. So the idea here was to see whether there is any advantage to having amateur signals in one part of the band or the other, relative to if they operate on the center frequency. If you remember that diagram with the band plans, we know that unfortunately the ATV block, if you like, goes right across the middle of the Galileo signal there. So they measured the impact of DVB T2 signals with a narrower bandwidth or a wider bandwidth, and they also looked at different narrowband emissions as well. Actually, in this study, there's no single sideband kind of signal, which was something we pointed out, but that's never been corrected, unfortunately. But yeah, quite an extensive program. And actually, we were lucky to be able to visit the location of the Joint Research Council of the European Commission, which, as I say, is down in Italy. And this is a proper setup. They have a huge anechoic chamber. The only thing I would say would be critical of is actually they have their radio navigation satellite service receivers on a 25-meter mast, which is a little bit perhaps not typical. Because they're living in amongst a whole load of trees there, so they need to be able to see the satellites to do their test. So that's one measurement campaign, and we'll just touch on the results of that. Oh, okay, yes, in the next slide. So again, this is just a small summary of the results, and again, we're looking at one of those receivers. There were 3, if you remember. This is receiver C. What were the characteristics of receiver C? I think they had a different bandwidth. Oh yes, at the bottom here, receiver A had a narrower bandwidth of only 30 megahertz, whereas B and C were 40 megahertz. And you can actually see some differences as a result of that, as you might imagine. If you go to the edges of the band, then clearly receiver A was much better. And you can see that in this text here, the benefit of moving the signal from the center. If you take a D-star test signal, for example, from 0 megahertz in the middle to 20.46 towards the end of the band, then we saw a 46 dB improvement for the receiver A, going down to 13 dBs, only 13 dBs improvement for receiver C, but still some improvement. So that's kind of interest. So in general, there was more robustness from the radio navigation satellite receivers to signals that were more offset from the center frequency. But there was a lower tolerance to wideband interference, especially when the emission is close to the E6 center frequency. I'm just checking my time again, so let's move on. In Germany, they did a very similar campaign. Let's not spend too long here. It's very similar. Again, they had a bunch of amateur kind of simulators here, They had some RNSS receivers set up here with measuring equipment. They identified a huge range of different signals to do tests with, as you can see here. They grouped them into narrowband systems, medium bandwidth, wider bandwidth, and then much wider bandwidth for amateur TV. And again, they picked frequencies that were consistent with our band plan, our use of the band, and the E6 center frequency. Again, the objective was pretty much the same, to understand whether there could be any benefit in moving elsewhere in the band. And I wouldn't dare to try and go into the detail of these plots, but basically they show an improving situation if signals move to the right. So clearly they found the worst case occurs with the center frequency. And again, frequency separation yields significantly higher tolerance to interference signals. And they also investigated a technology, a device known as an interference suppression unit, which was something that you could bolt in front of the receiver as part of the receiver system, which had the ability to recognize interference signals and well, ignore them or blank them out or somehow deal with them to make them less of a problem for the receivers. And these were more effective for narrowband signals. Oops, sorry about that. For narrowband signals, but not so effective for the TV signal. But again, what's important is there seems to be some scope to improve the situation. But again, it doesn't completely remove the possibilities for interference to occur. But anyway, major measurement programs. If we look at the interference cases, this is the one in Italy that I talked about. That ISPRA is down here by this lake. Sorry, the JRC is down here by this lake. The Italian repeater station is here on the hill, 400 meters above the surrounding terrain. It's only 15 kilometers. So you can see a huge spike on their response here at about 1297 something, which, well, in my opinion, I think it was probably causing their front ends to go into saturation. But yeah, this was giving them some problems. So it's very difficult to be in a situation where you can say, well, interference won't really occur, because they just say, well, look at this, So yeah, this was a bit challenging. Anyway, so what does it mean for us? What does it mean for us? This is what you really want to know. The first important thing to note is that removing the allocation is outside the scope of the work item. As defined in the resolution, very clearly says removal of the allocation is not a solution that can be considered. So that's beyond the scope of the work. So there will be an amateur allocation still, 1240 to 1300 megahertz. But I suppose the issue is, well, really then we'll have a situation where we may not be able to use the whole of that allocation in a way that we have perhaps up to now. And I think you can see that there's the possibility growing for the potential constraints on large parts of the band, in fact, for amateur and amateur satellite operation. I think it's fairly obvious from what you've heard so far. To deal with this, the Working Party 5A, the one I said is responsible for the deliverables relating to the amateur service, is developing a recommendation. And that's the vehicle that will contain these measures, this guidance, if you like, for administrations on the measures, both technical and operational, that can help to protect the radio navigation satellite system. And this approach is supported actually by the regulators in CPT, who see this as a good way to build a solution for addressing the agenda item in terms of the WRC. And as I mentioned earlier, there is a CPT thread to the work, and it's quite likely that ultimately CPT will mirror that guidance in its own deliverables within the CPT framework when they harmonize the use of the band for radio navigation satellite services. The fly in the ointment for us is that actually the European Union has the ability to deliver or to publish a regulatory decision, an EC decision for the EU countries, which means that guidance can be pretty much mandatory. So they can require the EU member states to implement that guidance in their national rules, which means it would impact, licenses in those countries. There is also a little bit of an unknown at the World Radio Conference, because, okay, recommendation sounds quite nice and soft, but actually there is a way to kind of mandate the guidance in the recommendation by incorporating the recommendation in the radio regulation by reference. This is where the radio regulation tables will say, as a footnote, if you like, against the allocation, that recommendation M dot whatever it becomes needs to be followed by administration in order to protect the RNSS. That means that then administrations are obliged to follow that guidance. So this is a development we're looking at very closely, and there could also be the potential for a so-called World Radio Conference resolution, which would say that the conference resolved that that the RNSS will be protected by following this guidance for the amateur service and so on. So there are these ways that can make it a little bit more less fluffy than just a recommendation for us. But that discussion is still to be had. Again, to give you a flavour of the proposals on a consideration, and I absolutely stress, please, none of these proposals are agreed at this time, but I share them because they're on the table at least. And of course, as the IARU are working very hard on this aspect right now, in fact, building our own proposals to put forward into the next meeting that will deal with these, which is actually in the middle of November coming up. So the guidance really contains three elements: frequency separation, kind of obvious that's going to come; power level restrictions, again, something obvious really; and excluding some applications from certain parts of the band. And then in these three boxes here, and I'll only touch this very quickly, there are three proposals that have been put forward by different administrations within the context of the work in ITUR. These are proposals only at this stage, but you can see they are saying, for example, higher narrowband operations only in the top 2 megahertz of the band, allow a block in the middle here, 4 megahertz for ATV, or they don't call it ATV, they call it for broadband applications, and so on and so forth. And then the one that usually attracts some raised eyebrows is a 5 milliwatt power limit across the remaining parts of the 23 centimeter band. Okay, we'll see how that goes. But then there are other more serious ones. For example, this bottom one here, there was a limit proposed for all amateur EIRPs to be less than 1 watt across the entire band. I would add that, by the way, the Russian Federation GLONASS system has an aeronautical component, and their studies are showing ranges up to 200 kilometers, as you might imagine. So this is also somewhat of a challenge for us to be able to deal with that. But the main thing is to say there are frequency separation, power level restrictions, and there may be the possibility to only use certain applications in parts of the band. And this is something that we're still discussing and still working on. So, as IARU, we are a sector member in ITUR. We have the same status, actually, as the European Commission in the ITUR. And we can make contributions to the study group work. And in fact, we have a chairman in the working group for 5A and so on. And our important elements have been, first of all, to make sure they make reasonable assumptions about the amateur services when they're doing their studies. And there's been a lot of toing and froing here about exactly what makes sense, because the studies include not just narrowband operations in ATV, but also FM repeater. They've thought about moon bounds, antenna tilt, all this kind of thing. All these things have been somehow considered in the studies. We also want to make sure it's important that not only are the technical characteristics, like antenna gain, like power levels considered, but also how we use the band. Really, how often are we actively using the band in with any number of transmitting stations? This is something, which is quite important to us, but it's been something that we have found the RSS community a little unwilling to pay some attention to, because it might not quite fit their narrative. But we're still working on this, and we're still making contributions on these aspects of the work. And of course, our aim is to try and minimize the constraints, or at least make them proportionate in terms of the guidance that may effectively come forward. This is kind of reflected in our position, which have been supplied to the WRC process here. You can read that at your leisure, but in essence, we believe the problem is overstated, and that the regulatory framework is already clear enough. And as I said today, we want to try and retain the ability for as many of today's applications, including TV, to be able to continue in some way as far as possible. Minimum of disruption to narrowband activities. And we will be continuing to work on this right up to the WRC and at the WRC. And now I can come to the last slide. So just recently, this is the sort of update. The Working Party 4C that I mentioned completed the study work, and their report has now been, I'm not sure it's been published yet. It's been adopted, as I think there might be some kind of consultation phase. But that work is done, at least in terms of the preparatory work for the World Radio Conference. So the technical studies are kind of, let's say, stable now. As I mentioned earlier, we have this next meeting of Working Party 5A, where we will continue to work on the recommendation. We expect contributions on the guidance to come from a number of sources here, not only from ourselves. We're developing our own contribution, but also these countries. China have been active, Russian Federation, France, and Japan, all been active in the work. And this meeting, I can tell you, is probably the most important one that we've had so far, in order to to have our chance to shape the outcome of the work in a way that we think is appropriate. And that is the last slide, actually. So I think that's not too bad. So I think that allows about 15 minutes, if I remember from the agenda, for some questions and things. And I'm happy to see how to deal with those. I don't know what's been happening, because it's like nothing happening on my screen apart from me.
No, that's okay, Barry.
Yeah.
Thank you very
Back
much.
to you.
Yeah, I'm trying to make that a little easier for you, because we expect quite a few questions on this, and indeed we encourage you, if you haven't already done so, if you'd like to make a question or comment to Barry, please do so. And whilst I'm not trying to filter those or anything, there's a couple of people quite upset about some of the things that this might mean for our hobby, of course. But
yeah, of course.
I'm sure you speak for yourself, Barry, and say that you're not making the rules. You're just trying to make sure, as indeed in my introduction, you're trying to ensure the coexistence of both amateur and professional use. So please don't shoot the messenger, I think, and be respectful to Barry in that. But having said that, Barry's put himself up to answer questions, and we'll read as many as we can to you. So put them now onto BATC or on Zoom, and we'll get through as many as we can. We might start our next speaker just a little bit late, because we want to try and get through as many as we can, and I'll try and spread them out. Firstly, the question that I'm going to read to you is on Zoom, and it says, from what I can, this is from Paul G6MNJ, from what I see from your charts, can I assume our digital ATV repeater with output on 1316 megs and input on 1249 megs should be okay?
Right, so yeah, thanks. Who was the guy?
That was Paul, G6
Paul, yeah,
MNJ, and the two
question,
frequencies, Barry, were 1316 out and 1249 in.
Yeah, so okay, so this is an interesting question, because it reminds me to that, of course, in the UK we have a slightly different situation, actually, to most other countries at the moment, because we have this additional part to our allocation, which is identified for us on a national basis, above 1300 megahertz, 1300 to 1325, is it 25 or 50? I forgot now. Up to 1325, but outside the scope of the studies, which are the top of those is 1300. So for sure, anything at the moment that we have going on in the UK above 1300 is not affected by the outcome of this work. So as far as the output frequency is concerned, it would seem to be, not likely to be affected directly by this work. But of course, the input might be at 1249. This depends a little bit on the outcome of the negotiations, basically, that we will, enter into, in particular, to try and retain some part of the band for ATV transmitters. As the work has shown, it's quite clear that the Galileo system, for example, is much less robust towards a broader band interferer than it is towards the narrowband interferers. So I think it's quite clear to say there's an expectation that probably operation of a wideband ATV system at any appreciable power level is quite likely to be difficult or challenging anywhere across the whole Galileo range. Maybe I can just jump back to that slide if I might, just to number 2, because that's the picture. I don't know if it's on the screen.
Yeah, we've got it on there now. Thanks.
Yeah, so I think 1249 is down here somewhere. Yeah, well, it may be that it's inside the looks like it would be inside the GLONASS block. Yeah, so it's difficult to be absolutely sure because we don't quite know how things will pan out. There is another issue here, of course, and that is that within the CPT there are some questions about whether CPT should be worrying about GLONASS now. I think you can imagine why. So there is some uncertainty about what might happen there. But at the moment, we're trying to. There is some. Let me say, how can I put it without being too positive but not negative as well? There is some thought to try and get a block in the middle here, which is wider than this gap because it's very narrow, and sort of equally shares a small bit of pain, if you like, for all the RNSS systems. They'll be wide enough to allow ATV. So maybe in the end, depending on how the UK react, of course, to these steps, it might be that input frequency might have to eventually shift one day. But the output would seem to be safe, at least for the UK for the moment.
Okay, thank you, Barry. I should intervene some of the obviously worries that many amateurs have, that many people appreciate all the work you're doing, as indeed I do, and thank you for that and defending our part of the hobby. If it wasn't for this, then we would just be at the bottom of the pile, wouldn't we? Now, this is from Justin G8YTZ. I'm going to summarise some of the points he's made. Autonomous driving does not require GNSS any more than a human driver does. GNSS is used for basic navigation right now, but later the AI only needs to read the road signs like we all used to do. Only systems that rely on HD mapping need this, and these systems, like GM Cruise, are not scalable. He says the Tesla FSD system just uses cameras and can work anywhere. And just to take part 2, summarise, he said GNSS antennas look at the sky, not terrestrial antennas. They just need to improve the GNSS antenna design and increase the FEC error protection on the GNSS signal. I don't know if you've got any thoughts on that.
Yeah, if you like. I mean, a lot of those points are really sort of having a commentary against the potential applications of these radio navigation satellites. So service users or system builders are saying they want to, be able to provide. I mean, clearly, they're making a system, they're trying to find applications for their system, and so on and so forth. I mean, in this kind of work, as I said at the beginning, the problem, the foremost problem is a regulatory problem that we have, driven by the status of the allocations for our services in this band. I mean, we can't go into a radio navigation satellite expert group and start saying, well, of course, your autonomous vehicles will never work. You only do this, only do that. We can only go by the criteria that the service have defined to protect their systems. And of course, I mean, they could make improvements to their receivers. They could improve the side lobe level, for example. They could, improve the tolerance to interference coming, horizontally towards the receivers. But then, how do you know that they're always going to be horizontal? Exactly. And even then, you still don't know where they are. So even those receivers that will be affected, because we are co-frequency, co-located, would still be, able to potentially see some interference. I think that the studies, I mean, okay, there's a lot of. I showed those plots earlier, which showed distances up to, less than 20 kilometers. I mean, I think you could imagine, as an amateur, I find myself also thinking about, does this seem about right? And, I know that if I have a 100-watt narrowband signal on 23 cents, into another amateur receiver. Now, okay, that's a slightly different scenario. The signal would be very, very strong. The signal they receive, without any kind of clutter or things like that in the way, would be very, very strong. So when you think about the propagation model being probabilistic and down to the 1% of time kind of time levels, I mean, I think you could imagine, well, it might be possible that they could see this interference. And of course, the regulatory situation says that they shouldn't have to tolerate that. And that's the nub of the problem. But yeah, I mean, we've often said, well, you can't, for example, declare that your system is a safety system for autonomous driving, because that requires a different kind of category of allocation, really, if you're going to declare this to be a safety service, and probably an exclusive allocation.
Sure.
So yeah, so we go only on, for our work, we can only use the defined technical protection criteria. We can't really use any commentary about the types of services that they provide. But these are all, valid points.
Understand. In fact, Mike Willis adds a comment here, which is similar to what you said, really. Amateurs are secondary users. It doesn't matter if the interference is to the system we don't see a use for or we don't care about. It doesn't matter if we were there first. If it was a primary service and the interference is above their idea of harmful, we have to adjust to prevent it. But I guess you're here to take the balance. This is from KN2K. Could you say some more on the implications for 1296 EMA?
Well, our so EMA is taking place in the narrowband part of the band. Yeah, I still have a slide on my screen. I'm not sure if it's on.
We can bring that on.
Yeah, why not? Yeah, this is the picture. Yeah, that's it. Yeah, again, we have the narrowband section down here, up here, I should say, which is where EMA operations are taking place. And our intention is to try to limit the impact on all the narrowband activities, in particular, to try and avoid having to move them in frequency, and again, to try and minimize the power level constraints that we might see coming in here. Now, of course, for EME, your antenna is elevated, and of course, this is reflected in the studies, because if you look into the studies, you'll see similar plots to those I showed, but the distances are far lower because you tend to be in the side lobe area of the antenna, but there's still not nothing. So, and of course, the on main beam, the EIRP of some EME stations can be very big. So I think in terms of potential implications, I think if there's a small change in the frequency, that's probably not too big a problem. This is what I heard from the EME guys in Prague. And I think that if we can keep the power constraint to something which is, not too unreasonable for us, then I think hopefully there's still good scope for EME activity. And as I said, it's always our goal to try and maintain as many of these things as we can. But yeah, I mean, if that doesn't work, then clearly the constraints would be probably power level. And we haven't got to the end of that discussion in RTU. This is the problem now.
No, okay. Thank you, Barry. Just to let everybody know, I have been in touch with our next guest presenter, and we are going to come to him a little bit later. We're going to try and get through a few more questions with you, if that's all right with you as well, Barry?
Yeah, I'm fine.
Okay. let me see. What about existing? This is from Mike G0LJF. What about existing CE-EMC regulations which apply to commercial equipment? These satellite receivers are presumably sold. Amateur repeaters may be considered not commercial, perhaps?
Right, so what is the question?
Well, I guess it's a point more, or just considering the amateur. I'll read it again. What about existing CE-EMC regulations which apply to commercial equipment? These satellite receivers are presumably sold, so they're commercial and they're out there and under those regulations. But I guess he's saying that maybe things we make ourselves and design ourselves, which don't have to comply to those same regulations, they're not commercial. So do they still apply?
Okay, so yeah, I mean, there's a statement that's kind of pretty much right. The receivers on from the radio navigation satellite service, like all communications equipment, commercial communications equipment, will be subject to well, let's call it CE marking as an abbreviation. That's not for the UK. We have a different one now. But there will be there is a standard, actually, a harmonized standard for those receivers, but it doesn't contain very much information. If you look into that specification, it talks only about spurious emissions from the receivers, and I think the blocking level is pretty much one parameter they define for the receivers. Other than that, it doesn't really specify much at all from a regulatory kind of perspective. Obviously, from a system perspective, they have some other kind of specification, I'm sure.
So they have to do the job they're designed for, I guess. But in terms of what they do, they're going to be the same sort. They're going to have to manufacture them to the same sort of regulations as anybody to comply with EMC emissions and susceptibility and things like that.
Absolutely. So yeah, and you're right. So as amateurs, we don't have the same requirements because our equipment is not on the market. But we do still have responsibilities to ensure clean and interference-free spectrum use and all that kind of thing. So it's not really something that's coming into this discussion, I have to say.
Okay, thank you. Tom Grady says, if the regulation proposed is that any signal between -134 and 140 dBm is just the noise floor, and that any interference above that noise floor is unacceptable. Rather than understanding that sharing this band appears to be not happening here, similar issues with UK 23 SEMS radar is not sharing the band, sharing in quotes.
Right.
It's quite a complex question. Should I read it to you, Ken?
No, I think if I understood correctly, I think so. The question is kind of saying, well, if we have these constraints, we're not really sharing.
Yeah.
In the sense that we're not using the same frequencies as them at the same time.
I think that's what Tom's saying, yes.
Right, yeah, this is... okay, actually, the terms sharing and coexistence can create quite a lot of debate, actually, within ITUR. But we won't open that debate here. Yeah, I mean, effectively, we are trying to... Let's say it'd be better to characterize it by saying perhaps we're trying to use the same part of the spectrum. It's clear that, again, it comes back to this regulatory situation that we find ourselves in, that we could be using the same spectrum as these guys so long as we didn't cause them any interference. So if there was no problem, if no one saw any interference or expected any, we could do everything we're doing today across the whole band and everyone would be happy. But we know that the interference can occur. And, as any amateur would find, if you look at this kind of diagram we had, it's pretty obvious that it could happen because we're co-frequency, et cetera, et cetera. So, yeah, I mean, it's true that we're not really sharing the whole band, but we're trying to find a way for the two services to coexist in the same spectrum and not and have the regulatory situation respected.
Yeah, so I guess the big things you're saying is coexist is a little bit different to sharing.
Yeah.
Living together.
Yeah.
Okay. Another question now from Gareth Evans. Didn't we lose a big chunk of 9 centimetres a couple of years ago? And if so, wouldn't split band repeater would ease the continued use of 23 SEMs?
Yeah.
I guess he's suggesting that to you as something that you may be able to put on the table if a compromise is needed.
Well, I suppose at the end of the day, it depends what we have in the as an outcome to the discussion. I think, again, from the TV perspective, I think it's quite clear that it could be quite challenging to find a block that is acceptable to everybody, that is big enough to allow reasonable use of the band by TV systems. But actually, TV is not the only broadband application. We've seen some data applications that want to use bandwidths of, let's say, a megahertz or something like that, which are experimental, and the people carrying out those experiments have as much a right, I guess, to have a space in the band as anybody else. So you can see it's quite a challenge probably to find a space big enough for TV operation in the band, even though we're trying very hard to do so. But I think, yeah, if we end up with this block of 4 megahertz around the middle, I guess our feeling is that we think that this, again, it may be a little bit challenging to get it, but if we can, we think that there is still the possibility for ATV systems to develop there. Whether you can have repeaters in one band, split between one band and another, that could still be possible. There's no reason why that wouldn't be possible. And I understand there's actually some advantages in doing this. It makes some of the, I guess, implementation a little bit easier in some cases. Yeah. So yeah, there's no reason why that wouldn't be possible. And again, it depends on what we really end up with at the end of the day.
Thank you. Coming on to our last 2 points now. The first one, Ian G8XZD says the typical bandwidths of the 1M and 10M for wideband operations seem very high compared to what is in use in 333 KS, for example. Are the parameters being considered unrealistic? He asks.
I'm not sure I quite followed all the 1M, 10M, meaning 1 megahertz, 10 megahertz.
I guess so, yeah. I just don't want to assume that my knowledge would tell me that, but it might be megabits as opposed to megahertz. So the typical bandwidth of 1M and 10M for wideband operations seem very high compared to what is used in 333 KS. So yes, probably a Ks.
Oh, okay. So you're talking about the sort of reduced bandwidth of digital TV, I guess.
Yes.
Yeah, I mean, we've tried to, let's say, in the course of the work, and particularly in some countries in Europe, it's been noted by some of the radio navigation proponents that there are still quite a lot of FM TV systems running, and these seem to operate in bandwidths up to like 16 to 20 megahertz. And we have taken a view that says that, well, perhaps this kind of operation is really in the future not perhaps consistent with what we are being encouraged to do here in order to coexist in the band. But as far as the studies are concerned, then all these things can be studied. Obviously, it depends on what conclusion you draw from them. But we don't want to constrain ourselves too much. So in the beginning of the process, of course, we're going to try and achieve as much bandwidth as we can for wideband broadband systems. Maybe as the negotiation goes on, because as I said, it will be a compromise, and it depends to a large extent on the willingness of the RNSS community to compromise and allow the possibility for some small amount of interference, maybe in a part of their band, but hopefully in a part of the band that doesn't cause them too much grief. That compromise will be important in order for us to find these kind of solutions. So we don't want to force everybody to have a solution that forces everybody to go to super narrow, low symbol rate TV, because I understand that not everybody is kind of starting in that place, and maybe you need a few more megahertz of spectrum than just the narrowest chunk.
Yes, fine, thank you. In fact, Nicholas Grundy says something similar, maybe working on a lower bandwidths would be possible. And of course, that's something that digital has enabled us to do recently. I'm going to leave the last question. I'm sorry I've missed a few of them, but we do have to move on. I'm going to leave the last question to Rob, M0DTS, who says, how do the various radar signals in the band 1272 megahertz up here affect the situation? I assume they'll have to move, he says.
No, so this is, I didn't really touch on the radars, did I, much, but the radar systems work under the radio location service. Excuse me. And the radio location service is also a primary service within the band. Excuse me. And they were there first, basically, which means that, in effect, the radio navigation guys, the Galileo guys, cannot do anything to prevent those radars from operating. They're a primary service. They have every right to operate in the band, and Galileo can't expect to be protected from them. So the Galileo system has to put up with them, basically, and which is quite interesting because you know, you can imagine a radar system is quite usually occupies quite a large bandwidth, and quite often with a very, very high EIRP. But they know this is there, and this is something they've had to deal with from the start. So the Galileo folks tell us that their receivers or receiving systems can cope with the repetitive pulse nature of radar interference. And then they use this a little bit against us by saying, well, that means we already have to take some hit in this band in terms of the amount of spectrum we can use. So, you know, we really want to minimize the potential for interference that we have from the amateur service, unfortunately. But yeah, so they know about the radars. It won't have an impact on the radars. The radars will still continue. The radar service can develop. It can put as many new radars in as it likes. And the radio navigation satellite guys have to put up with it. And yes, you have to wonder, well, how well is my Galileo-controlled autonomous vehicle going to behave driving around the perimeter road of, I don't know, Heathrow Airport or something, if there's a big L-band radar going on there. But that's another story.
All right.
It's not within the scope of the study. This is the issue.
Okay, Barry, thank you very much for all of your explaining. As I mentioned at the beginning of these question answers, clearly feelings are running high, and I'm sure we all understand that. But I think I speak for everybody who say we're very grateful and for that you, as an active radio amateur on these sort of bands as well, are helping to represent our cause on the ITU. And we wish you well and thank you for all your work on that.
Yeah, well, thanks, Dave. And let me just say, you know, it's not just me. We have a little team of guys. We have a focus team in the IARU about from all the regions, and in fact we'll be collaborating just this next week on our contribution for 5A. So yeah, so I'm the lead for the team, but you know, it's a team effort, and you know, we are really trying to fight very hard to do our best for the amateur service here and retain everything or as much as what we do today in the band to the best that we can.
We can see that. Thank you ever so much, both for your talk today and your presentation today, and also for all the work that you're doing for us behind the scenes.
Thank you very much.
Barry, G4SJH, thank you very much. Now, we're a little bit late running, a couple of minutes late, but we'll be shortly going to Benno for the update on all of his software developments and DATV Easy software. We'll be back again in a couple of minutes. Welcome back. Our final presenter today is Benno, PA3FBX. Benno is one of the most enthusiastic DATV operators on QO100 and is also heavily involved in keeping the DATV repeater PI6MEP on the air. As one of the beta testers for DATV Easy, he's offered to now demonstrate and explain the software which enables most modern PCs to generate signals for transmission to QO100 with just the addition of an SDR. And remember, if you've got any questions or comments for Benno, just pop them onto BATC or Zoom message and I'll read as many as we can to him after the presentation. But now, welcome to CAT22, Benno.
Good evening, good afternoon, guys.
Good to see you.
I need to mute myself.
No, you're fine. You're fine.
Okay.
Yep.
Well, thank you for that, David. Marvelous presentation from Barry. Thanks for him and handling our goals or our frequency. He's trying to keep at least a little bit for us. Thanks for that. Good afternoon. My name Benno, PA3FBX, and I want to tell you something about DATV Easy. I prepared a small presentation, takes a few slides, and I think it covers most of the information. Let's see, where are we? In the old days, we had analog TV. Because more and more programs needed airtime, more channels needed to be squeezed in the frequency band. DATV was implemented. A big improvement in quality, a better range with low power was the result. The only big problem was the fact that digital encoders were very expensive. Then QO100 came and the need for affordable DVB solutions was really born. All over the world, groups of hams made projects to improve the usability of DVB systems. And from France, we got, the advanced technology didn't slow down, but really got onto speed with Everest DVB firmware for the Pluto. So how did that work? A lot of people already know the Pluto. His contribution to the modification of the Pluto firmware to accommodate digital video made digital video broadcasting transmission much more active, and lots of hams starting on the narrowband, moved on to the wideband with this help. F5OEO is by now a famous call sign, and lots of hams adopted his work. It simply takes the output of a streaming program and puts it on the air. H.264 was the normal encoder, and you needed, again, expensive hardware externally or internally to get H.265. Which had better compression to get more video results in low bandwidth settings. Several specialists started to use FFmpeg scripting, and F1 Echo Juliet Papa managed this into a user-friendly software tool to get H.265 out of a software codec. So Pluto, the F5OEO browser, some streaming program, and an extra tool in between to get the H.265. It got really crowded on your PC screen. So you would need OBS or vMix or any other streaming program. You need some kind of FFmpeg encoder. You need obviously the browser to control the frequency and power settings. You also would like to have some kind of chat box and frequency monitor. If the frequency is free, then you need some receiver to receive yourself or another station, which was also on the air. My screens were completely blocked, and obviously this could be solved by more PCs. So you have 1, 2, 3, or even 4 screens. But more screens is more difficult to manage, as you might know. Another problem was the fact that the line was only supported by Portsdown at that time. So Dominic started to work on a coder like FreeStream, but to control the line. That was the born of DATV Easy. After many requests, some Pluto support was also added, and the main advantage of that was DVB-T, which was suddenly possible to transmit without the use of Portsdown. The layout was simple. On the left, some mode settings, in the middle, some video settings, on the right, some audio settings. Oh, sorry, in the middle of some audio settings, and on the right, the frequency, power settings, and obviously the start and the stop. It took the better part of the summer to get a decent release, which is now available. Some days we beta testers got 2 or 3 updates. But now we get inputs from OBS 27, but also from 28. We get user-friendly settings for modes up to 2 megacycles and DVB-T. We get all kind of outputs for the line, for the Pluto for analog devices, firmware, and for F5 OEO firmware. And somewhere along the line, we also got some monitoring control, which is handy for those guys using the remote stations. So if you would know FreeStream encoder, you quickly feel home in the settings, which are like which kind of hardware, which kind of network address, which kind of video stream program, hard or software encoder, audio settings. You just enter the call sign and your program information. Don't change anything else unless you know what you're doing. Finally, change the frequency and power settings and just press start. DATV Easy will overrule all the Pluto settings and start the transmission. Selected on frequency, sample rate, frame quality, audio settings. So if you want to remotely monitor your amplifier status over the network, DATV Easy supplies an Eno for an Arduino Uno. Be aware, use the Uno with the corresponding shield because Eno will only support this chipset. Or in my case, I used a Raspberry, just an older Raspberry 3 in this case, and I put Node-RED on it. And I get a decent screen on my computer, but I don't want extra screens. So DATV Easy incorporates the last part, the settings for the temperature control and also the digital output with several delayed switching stages for each amplifier stage or bias control. So for those guys who like flow diagrams, this is an overview of DATV Easy. On the left side, you have some kind of audio or video capable mixing into some kind of broadcast picture. On the right side, you have a line, a Pluto, some Arduino or USB control. DATV Easy is combining FFmpeg scripting, GNU radio monitoring calculation, and user interface to set up and transmit a stable output onto the air. So a lot of questions already I got from lately. So why would I need DATV Easy? If you're happy with your current setup using Portsdown, if you're using a hardware encoder due to a low-end PC, if you're completely happy with your current setup, or if you're a MFMPEG guru making much better quality streams in a certain transmission, I would guess you don't need it. But for all other hams like me who are changing their frequency and quality settings and want an easy transmission with a good quality, don't want to bother about null packets or audio dropouts, and would like to have a setup for a remote controlling and monitoring for your own amplifier, I would guess take a look at DATV Easy. It really makes DATV easy. So I finished already with some questions I recently got, and it might already answer a lot of basic questions. If your PC is a bit older, just give it a try. If you want to know, just test it. Under F5OEO firmware, it makes the use of UDP, which is much more light on the CPU, much like the free stream encoder. If you're using DVB-T or for the line, you need a stronger PC. It runs on 10 and 11. On all the previous versions, you just have to try. Can I use my Intel or NVIDIA card? Yes, it uses several hardware encoders if available. If not, you can use the software encoder. Will OBS 28 work? Yes, since this week, we have support for DroidCam, Virtual Cam, and virtual audio cable. Will it run on my Pluto firmware? DATV will run on the original AD firmware, but you need a stronger PC as it uses RTMP. It will run also on both the current latest, I would say, F5OEO versions with UDP. What mode does it support? Obviously, it supports all the current DVB modes like DVB-S, DVB-S2, DVB-T, anything in 20K up to 2 meg, and in H.264 up to H.65 in 15, 25, and even 30 frames per second. Audio, all the current in even 44 or 48 sampling. Will it run on my networked Pluto? Yes, it will run on USB and also on network connected Pluto, and obviously on the USB connected Lime. So where can I find it? Well, that's the next question. It's downloadable on the Viva DATV forum from Everest. Where can I find the instructions? It's downloadable. Yeah, you find it in French and English on that site. Please read them and follow them before reporting the problems. It really improves the quality if you are following that instruction to the letter, as you also have to modify a little bit on the virtual cam if you use it on the OBS. Where do I find the help? Well, both Dominic and myself and several other beta testers will monitor the BATC and AMSET DL fora frequently. So find us there and put the questions in there. So I have a little bit time and I switch a little bit to how it looks. Let's see if I can quickly do that. So this is my DATV instance, which I'm currently running. Like I said, currently running on 2.08. On the first screen, like expected the transport, you just choose the mode if you want. Mind you, DVB is not in here. I will show you that later. The symbol rates, the FAC, the roll-off, then modify the bit rate. Choosing this automatically chooses a bit rate for the image and the audio. If you want to modify that, it's not a big problem. You just unclick, but I know if you go too high, you might freeze up your FFmpeg. So it's always wise to use the automatic image. On the next tab, you see I've selected F5 OEOs 0201, which is currently in my setup. But I also can use the Pluto, which is the analog devices, and even 0201 works, no problem. You can still use it. You see my, it's my Pluto is networked. You choose the OBS, or you want to vMix, or any other IP address. So I need to put that one back. And you choose the encoder like Intel, AMD, or Soft. And I am lucky with an NVIDIA encoder. Then for the lip sync problems, we know lip sync is the big issue lately due to all kind of FFmpeg limitations. And now you have the simple solution, and you can change the lip sync here. For my system, it's -300. You can go up to -2 seconds or +2 seconds, if you whatever you want. Your sample rate for your audio is also here, as well as the frame rate if you want to go on 30. So on the DVB, you have your call sign and your name or your program information. This information below here, leave it automatically, but if you are changing it, it will only active if you're not using F5 OEO, as F5 OEO is changing this in the UDP stream. So on the RTMP stream, you'll be able to go to a different PID settings. But then again, you need a decent PC with the Pluto selected. And in this mode, you can also find the DVB-T. So this about the normal settings, and I quickly move that one back before I forget it. And then finally, you have the PTT monitoring. It will select the Arduino you find in the ini file in your system, and it will read out the information from your amplifier. There are 4 stages of switching. So if I just put them below each other, it switches at the same switching point. If you put them like me here, you have first this one and delayed this one and delayed this one. And I told you 4 because you have actually a real PTT. So I just start up. I hear my relays switching. My power amplifier is now under power, and I can switch on the PTT, switch off the PTT the way I want. Adjust the power setting. One thing I haven't spoken about yet, and I've shown you already in my display. I stop this. I'm transmitting on this frequency. You need to start using a different way of looking at frequencies. For instance, if I'm going to use the local repeater, I can choose it this way. And if I want to go on the Q100, I just select this frequency and I have this frequency selected. So this is the new way of the DATV Easy selecting the frequency. For me, in first, I was getting start using clicking on the browser, but after a quick while, this started to use. So I'm easy to be able to transmit, and I won't do that obviously because Mike is occupying that frequency. So let me show you a little bit about the Arduinos if you don't know them. Let's quickly go to my desk cam. Okay, I have some Arduinos here. This is the Arduino Uno, and you need this big shield. I also have this one with a nano, but I cannot get it to work as this one uses different chipset where something in the Uno is still not getting to work with this chipset. Or you use something like a Raspberry 3 or a Zero or any old Raspberry with no Node-RED. It doesn't really take a lot of information. Actually, my Raspberry is being used for Node-RED, but also for the long mind for DATV reception, and also for port forwarding, getting my Pluto onto my network. So it's used 3 ways, which is just still a Raspberry 3, and I don't have any hardware issues. It's running at a very low profile. Okay, well, that concludes what I wanted to talk about.
Okay, thank you very much, Benno. Covered quite a lot there, and this is a great opportunity for you if you'd like to ask any questions to Benno about his software or anything else at all. He'll try and cover it, I'm sure. Just put them onto BATC or the Zoom text messaging and we'll read them to him. Someone who's done just that is Michael EA7KR and said, is the source code available, because I'd love to see it running on a Mac?
I have to ask Dominic what his presentation, his way is. I'm not sure if Dominic is releasing his source code. He's putting a lot of work in it already. I'm not sure his current state. He is asking for more implementations, and this might just be an idea additional to get it to work on a Mac, as I know he's using it from.
Yeah, on a similar, actually almost the same question really, from Justin G8YTZ. He just asks if it's going to be available on a Mac M1 portable, which is using the Apple Silicon, isn't it? So I guess it's the same sort of question really. Hopefully you and your colleague can think about that. Nick G1BVI says, can you use it with a Portsdown 4/Lime USB? Did not notice it in the drop-down menu. And what does PTT control? Thanks.
Well, start with the last part, PTT is actually the 4th relay. It just starts. It's capable in switching 4 different stages, different relays, actually, to control your amplifier, your power to the amplifier, your pre-stages, in what kind of order you want to start them. On the other part, I wouldn't see why not, because I know Freestream was capable in doing the same with UDP to the Portsdown. I have used that on Portsdown 4. So I guess I would have a go on that, but I think I'm not sure what it does with the H.265. I know at that time I needed to go back to H.264 to get through the Portsdown, as it works with H.264.
Okay, thank you, Benno. Somebody, Majaz, I think, I'm sorry, I hope you got your name right, S59MZ, asked, where can DATV easily be downloaded from, please?
So that was on the slides. I just quickly move back. It's on the French site where everything from Everest was found in first, and also the mini tuners software is found, which is the Viva DATV site. Let's see if I just went too far back. Okay, let's move back to the to that image.
I think Fred Marinus has just put a link on Zoom, but obviously if you're watching this on BATC, you may not see it. But there we are. That's on the screen now for you. Thank you, Benno. vivadatv.org, and then that link there. I guess there'll be a link and an index from the front page.
Yeah.
Okay, thank you very much for that. Someone else, John, has said, I'd love to see DATV easy on Linux. So there we are. There's the 3 platforms. Requests for Mac and Linux for you. Dave at work. That's all I've got in terms of your name or call sign, Dave. I'm getting about 3 dB less power from my Pluto using easy DATV than using Freestream Coder. Is this something that you've usually seen?
Well, actually, myself, I found it. I got more. So that's, I think, back to what kind of firmware did he use? Because if he is using the 0303, we all know that one reduced 3 dB. So I would guess stay below 0201, which was the last non-persevere version of F5OEO. And I think I would investigate in that.
Okay, thank you. Actually, someone else asked, Justin G8YTZ asks, is the latest version 2.08? Do you know?
Yes, it came out last Monday morning. And so, yes, at this current moment, I know there are already some issues, and as these things progress, 09 will come within a week or two, I believe.
Good. Associated with the same low power question, Clive G3GJA says, I've tried the program on 2 different systems. Both have produced much lower power output, though, compared to with a Portsdown. I've seen this reported on the BATC forum too. So your message was to check the firmware version.
Yeah, I think it's probably somewhere around 0303. But again, I found that the latest DATV versions did produce the same or even a little bit better power.
Okay, thank you. Phil M0PIT says, I've rewritten your script and created a bash script. I can now send RTMP stream from OBS into FMPEG without the virtual cam using H.264 and H.265.
Sorry, who was that?
That was from Phil M0PIT, Papa India Tango.
Mm-hmm.
So he says that he's rewritten your script and created a bash script from that, and so that he can stream from OBS.
Okay, it's not my script, by the way.
Okay.
It's I just present the information from Dominic.
Well, I think what we've learned today, Benno, is that everybody's work seems to be collaborative, and there's probably very few single pieces of work from any one person. I think we've covered most of the questions and things there. I want to thank you very much for giving us this presentation this afternoon, and for all your work and collaborative work with your colleagues on that software. And thank you very much for joining us on CAT22.
Yeah, thank you for having me, David, and everyone have a nice weekend.
Thank you. There we are. Thank you very much again to Benno PA3 FBX. Now we've got a short video before we conclude CAT22. Just a quick look at some of the things that we do in our club. Well, I hope you've enjoyed joining us for the British Amateur Television Club CAT22 Conference Part 2. We hope you really have had fun today. Although this has been a live event, all of the presentations have been recorded and will be put up onto the BATC YouTube channel very soon. Now, if this is one of your first experiences of the BATC, then maybe you'd like to consider joining us, because membership starts at just £8 a year. You can find full details about the club at batc.org.uk. But now it's over to the BATC chairman, Martin G4FKK, to close this year's convention.
Yeah, thank you, David, and to everyone who's contributed. Fascinating part 2 of CAT22. I think everyone will agree there was lots to be learnt there, and some interesting things perhaps to worry about as well. I'm particularly worried in the fact Tom and the wise men of programming keep saying, oh, it's easy to do this, easy to do that. So I've decided when I finally retire, which is in the next few weeks, Node-RED is going to be one of the things I have a go at learning. But so Tom, ZR6TG, amazing stuff. And as Noel intimated, possibly we could have a discussion about the BATC bursary scheme to get your Apple stuff or get your stuff ported to Apple, as it were. So that'll be an exciting thing as well, and just amazes me what you can do really quite quickly. There's a number of members of the BATC who Rob's another one, M0TTS, who says, I've not done much this week. Oh, I've just written this little program which does amazing things, and we can all learn from that. Dave, GKQ, thanks for the Portsdown. And I have to say, the Portsdown, especially if you've got Lankstone installed as well, with all the test gear, it's just an essential part of shack equipment these days, let alone just for DATV. And thank you ever so much for your ongoing support of the stuff you've already done and the continuing development. That's all very exciting. And Barry, G4SJH, well, all I can say is good luck with the up and coming meetings, and we've all got our fingers crossed that we can maintain as much of 23 SEMS as possible. My theory is they shouldn't have stuck flipping sat-nav there in the first place, but what would I know? And Benno, thank you for a very clear description of how to drive DATV easy and the history of it. And having spent a number of hours in the past trying to get FFmpeg scripts going, and it is possible eventually. It's like FFmpeg in a nicely packaged GUI. And of course, we've got to thank all the other developers of software that haven't been on the meeting today, but Evereast in particular, F5 UII, and loads of others too. So just as a final thing, I'd like to thank all the speakers. I'd like to thank you, Mike, G0MJW, for sparing your electricery to, I imagine we'll expect an invoice at some point to relay that on Oscar 100. I know Dave's been relaying it on the BATC streamer. And of course, finally to David and Tammy. Tammy, I don't know if you notice I've got the screen share going on, but here's a picture that David took earlier of the number of computers it took to make this presentation work. And I think everyone will agree, and I certainly maintain that was a thoroughly professional broadcast, and the sort of homemade TV gallery there, it looks very impressive. Okay, so thanks all for joining today. I believe we've had 200 people watching via, or over 200 people watching via Zoom, and the PAT streamer. As David says, it'll all be out on YouTube soon. And I'd encourage anyone who's not a member already of the BATC, it doesn't matter whether you're in the B, as in Britain, or not, you can join anyway, and there's all sorts of huge benefits. Thank you very much. Goodbye, and we'll see you either on the nets on Thursday or on the next CAT23. Cheerio.